Hello, everybody. I hope you're all having a wonderful evening. We are about to kick off some amazing stargazing this evening. I just finished setting up the telescope, and I'm so excited that you're all here. So, first off, where are you all watching from? Hello, hello. And my name is Athena Brensberger. I am the new host of Nova's YouTube series, What the Physics. And tonight I'm going to take you all stargazing and deep sky observing with my telescope. We're going to be looking at tons of different objects. Some of them are going to be close to us, like our nearest celestial neighbor, the moon. It's about 240,000 miles away. And we're going to be looking at objects really, really far away, like our nearest major galaxy, which is Andromeda, at about 2.5 million light years away. So, hello, everybody in the chat. Hello, Paul. Oh, we've got someone from New York. That is awesome. Oh, hello from Wisconsin. Hello, Brittany, Susan, Loki B, Richmond. Oh, that is so amazing. We've got Science Mom in the chat watching from Alaska. Oh, incredible. Well, you've got some clouds by you, but I have got clear skies tonight. So, we've got some incredible objects lined up for this evening. So I'm so glad you all are here. I just want to let you all know too that we have one of Nova's fact checkers here to provide extra information and facts within the chat all throughout the stream. So they'll also make sure that all the facts that I share are accurate, especially if we decide to look at something impromptu. So huge thanks to them for being here, and look out for them in the chat. And let us know if you have any questions about any of the celestial objects we will observe. So let's go ahead and kick it off. Again, hello, everybody. If you're just joining, this is a moon party, and we are going to be also looking at stars and lots of other planets. So let's go ahead and jump to what my telescope is seeing. So I'm going to go ahead and share my screen here, and feel free to ask questions all throughout the stream if you'd like. Now, this right here is the moon. Oh my goodness. It is just so breathtaking to be able to see it. I've got this currently about 2 minutes and 40 seconds. You can see right down here. Let's see if you can catch my mouse. So right at the bottom, you're going to see the center one is the enhance feature button. So it's enhance this image more. It's going to bring us some of those crisp details that we can see here of the moon. And we also can zoom in quite a bit here. So we're going to have a lot of fun with these tools. And then right here is a camera button. So I'm able to snap these photos. I can share it later if anyone wants to check it out. But let's jump into it. I love these questions so far in the chat. This is so incredible. Yeah, yes, this is live education. This is a live stream, live viewing of my telescope right now. So we've got such an incredible view. It's almost a full moon. So right now, this is about an 89% illumination. So that means it's about 89% full. And it's approaching its full moon phase, which is going to be on December 15th. So if anyone is going to be looking out for the moon on December 15th, that's when it reaches its full moon phase. So definitely look up at the sky and check it out and see if you can see any of these craters. I mean, look at all these markings on here. Has anyone in the chat seen a detail image before like this of the moon? I want to hear from the chat. Does anyone at home have a telescope? Anyone with binoculars? Would love to hear if you guys have been able to see the moon like this before. So let me know. Even you could even see it through binoculars. And yeah, let's kind of jump into what you guys have all seen. Yes, I have. Oh, amazing. That opal guy. Right on. Oh, December 14th is my birthday. That is awesome, Yad. Happy early birthday. Am I a moon? No. I mean, I'm guessing you were probably a human, but maybe one day you can visit the moon on your birthday. So I'm curious, does anyone know the name of this upcoming full moon on December 15th? Has anybody know the name of this upcoming full moon? Now, they all tend to have different names. You can always name the moon yourself, give it a name, But there's a lot of different names that tend to tie into the time of the year or some mythology around it, or just sort of what people were observing at the time, depending on how large the moon looked, or during certain seasons. So, what would you name this moon, and what do you think the name of it is? Let's see. The Gemini moon, nice. They name full moons. Yes, I mean you can definitely name a full moon as well. Oh, amazing. Thank you, Nova, in the chat for saying, yes, this is a unistellar digital reflector telescope. So that is how I'm able to connect the image right now to, I'm actually streaming it on a tablet, and I'm able to share the screen to my computer. So it all is through an app, and it is able to bring us this live viewing of um, of what we're able to see in the sky. And it's something cool about it is really able to cut through some light pollution as well and bring us these really crisp images. Okay, let's see. Aquarius moon. Okay. Hunting moon. Karen, that's a really cool name. So this one, there is a hunting moon. I believe it might be in October, November. I'm not quite sure if anyone wants to double check that. I have heard of the hunter's moon before. But this one, I saw a few comments in the chat of people talking about how cold it is. It's really cold time of the year. So this is called the cold moon. And it is indeed affiliated with, well, the cold evening. So this is traditionally known really as the cold moon, and it reflects both the chilly temperatures, but also the long nights that tend to happen in the northern hemisphere. And this is, yeah, such an incredible view that we've got here. We're going to zoom in just a little bit here as well. We can kind of check out closer area. If you want me to zoom in, let me know. Snap another photo there. But this moon is not just called the cold moon. There's actually a few different names that the moon during this time of the year has received, and from different places around the world, such as the drift clearing moon, which is from the Cree tribe, or the frost exploding trees moon, or the moon of the popping trees, which is from the Oglala tribe, or the Hoar frost moon, also from Cree, the snow moon from Haida or Cherokee, the winter maker moon from Western Abenaki, moon when the deer shed their antlers, Dakota, and the little spirit moon. And now I think that is so fascinating how each of these, I mean, you think about the names, the winter maker moon, when deer shed their antlers, the hoar frost moon. These are all affiliated with different things that have been observed during this time of the year. And then in Europe, you also have the Yuletide moon. So this is usually the full moon before Yule in honor of the Yuletide festival, which is an ancient pagan festival that would happen in December, and also would mark the return of the sun, heralded by the winter solstice. So pretty cool to think about that name. But what else? What would you name the moon? What would you call it? The cold moon, moon tower. Yeah. So pretty cool facts about the moon. We've got a lot of things geared up here tonight. But I'm going to jump into, where do you think the name moon comes from? You guys have probably heard about maybe the word moon in different languages. Why don't you type it in the chat? What are a few different ways of saying moon in different languages? I'd love to hear also your language, whether it is English or your native language, maybe a totally other different language. I would love to hear what you would call the moon. Luna, yes, Karen B. Guzman, very, very popular name, Luna. And so Luna, does anyone know where that derives from? Where does the word Luna derive from? And what does it actually mean? It describes something. I'll give you a hint. It's a color. So where does Luna come from? Chand is one in Urdu. Ah, really nice. Okay. Kamar in Arabic. Finnish, cool. Sailor Moon, Sailor Moon's cat. I have a cat who's actually about a similar color to the moon. She is a gray cat. Milk, yeah, from the Greeks. Okay, Matteo, so from the Greeks. So Luna is actually from Latin. It's a Latin word which describes the color silver and actually shares its name with all other moons in the solar system because, well, people were not aware of any other moons that existed until Galileo discovered moons around Jupiter in 1610. And for those wondering, yes, we are going to also be looking at Jupiter, so make sure you stick around because that will be the next celestial object that we are going to check out. So let's get another photo of this. And does anyone have any moon facts that they would like to share? What about the first time that you saw the moon in the night sky? Can anyone remember? When was the first time that you saw the moon? I remember seeing the moon when I was a little girl, and it always inspired me. I'd always thought, man, I've got to go there one day. And what's interesting is the moon actually has a direct influence on the Earth in many ways. One of them is actually the gravitational pull of the moon. It causes Earth's tides. Both the moon and Earth are massive objects in space, and this causes them to have a strong influence of gravity. You know, the thing that kind of holds you down to the ground. If you jump up, you'll fall back down. That's the influence of gravity. And both bodies, both the Earth and the moon, exert gravitational pulls on each other. And when this happens, it causes oceans on Earth to swell. This is what, yeah, when if you hear about high tide, it's high tide. Like, you know, some surfers might like it. Other people might say, hey, maybe avoid the ocean at this time. Don't go out swimming. But that's where we get our tides from. So without it, our oceans would actually be a lot calmer. Now, has anyone ever heard, let's see, we've got other alternate moon names. Oh, that's super cool. Yeah, almanac.com. The almanac is a great place too to learn some more things about astronomy and what you can actually catch in the night sky, specifically a lot of things around the moon. Let's see. All right. Oh, so we have I'm right, you're wrong in the chat saying that the moon is the only moon and the other planets just have natural satellites. Does anyone want to chime in on that? On what that may mean and what you actually, if I'm right, you're wrong. If you want to elaborate a bit on that thought, because I've definitely have some thoughts to share there about what you shared. Okay, let's see. Matteo says the footprints left by astronauts on the moon during the Apollo missions are still visible because there is no wind or atmosphere to disturb them. That's so cool. I actually have some notes to share with you all. That is one of the cool facts I was going to share. However, there is a slight atmosphere on the moon. It's very, very thin, especially compared to Earth, but there is actually an atmosphere. And let's see what else. Right on. Okay. So often referred to as Earth's natural satellite, the moon is indeed also a natural satellite. A natural satellite is something that would orbit a body like a planet. And, you know, we have satellites in space giving us GPS navigation, telling us the weather. There are lots of satellites, but a natural satellite would be referred to as the moon. And we've got a fact checker in the chat if they want to just double check that. But the calling it a natural satellite is totally normal versus sort of saying that the moon is the only moon, because they are one and the same when it comes to orbiting a planet. So yes, Jupiter does have lots of moons. Saturn has moons. There are lots of natural satellites. So now, how about the far side of the moon? Has anyone heard about the far side of the moon before? Often called the dark side of the moon, although, you know, it is still, it's not necessarily dark. It's just not facing us. Has anyone heard about that before? Well, the same side of the moon always faces Earth because of the moon's rotation. The moon's rotation matches its orbit. And so it's always facing Earth whenever it circles around our planet. And this is called tidal locking. And this is why we refer to the far side, not visible from Earth, as the dark side, because even though it technically does receive sunlight, we can never see it on Earth. It's the far side of the moon. And really cool too, the far side of the moon once had erupting volcanoes. So erupting volcanoes. So incredible. On top of that, I want to talk a little bit about some space missions. So we're going to go into a little bit about, oh, yes, thank you, PBS Nova official in the chat. We've got a confirmation that the Earth's moon is also considered a natural satellite. So there we do. We've got a nice confirmation there of those two terms. But we're going to jump into a few locations of where there have been moon missions before, both robotic and with people. Now, since we're talking about the far side for just a moment, I want to share a little bit about some new research that confirms that the moon's far side actually experienced volcanic activity billions of years ago. Billions of years ago. I mean, volcanic activity. Can you imagine being on the moon when volcanoes are erupting? So similar to the near side visible from Earth, and samples obtained from China's Chang'e's 6 mission. I'm probably not really saying the name right. I can say that the ISRO's Chandrayaan perfectly, which is like a really long, really long name, but China's Chang'e 6 mission. Can't pronounce that name correctly necessarily, but feel free to correct me in the chat if you've said this several times in the past. But the actual mission, so this mission has revealed that volcanic rocks dated around 2.8 billion years old. So this indicated prolonged volcanic activity on the moon's far side. So that's so incredible that this has come through. Does anyone have any cool facts they want to share about the different moon missions as well here before we move into a few different landing spots, like locations on the moon? Education. So this must be why it has all the lava tubes. Oh, so much to talk about with the moon. The lava tubes is a whole other area to explore, but yes, yeah, the lava tubes on the moon. There's so much to explore. But what we're going to look at right now, someone had mentioned earlier, the atmosphere. So there is a thin atmosphere, but it's nearly absent. It's barely there. And so there's also a lack of water. And this means that there's almost no erosion. So we expect that the footprints left by the astronauts during the Apollo missions will remain visible for millions of years. And then also the moon's weak atmosphere and its lack of liquid water can't support life as we know it. And so we would need to have very top-notch, great habitats to be able to be on the moon and to survive. So something also really cool about the moon's atmosphere, it's about 100 trillion times less dense than Earth's, making it nearly a vacuum. Now let's explore a little bit about where different landing sites have been on the moon. Does anyone recognize anything in our view right now of the moon? Any specific areas that may have been landing sites? There's been more than 105 robotic spacecraft that have been launched to explore the moon. So, and it's also the only celestial body beyond Earth so far that has been visited by humans. So pretty cool. But let's take a closer look here. Let's see where where there have been space missions already. And I'm specifically talking about the Apollo missions. Does anyone recognize anywhere here in our view of the moon where the Apollo missions have been? Yes, education, the Sea of Tranquility. So let's zoom in just a little bit here. So we have the Sea of Tranquility. I'm going to zoom in just a little bit. It's this upper right region right up here. So right at the top of the screen and then just above my head, we see two massive craters. Now, these are really they're specific kinds of craters. These are known as basin. So what would you say would be the reason that these would be called? Well, actually, I want to share. Do you guys know what the names are of them? So we have Sea of Tranquility. Does anyone know what the second name is that we have here? Sea of Tranquility. Sea of Storms. So we've got a lot of seas being mentioned. And until we get the second one mentioned here, I don't see it just yet in the chat. Why the sea? Why are these called the sea? I mean, that just seems so crazy, right? I mean, like a sea. Does it look like a body of water? Well, no sea there. Yad. Yeah, exactly. There's no sea there. So why in the world would they be called the sea? And Science Mom Serenity. Yep, we've got yes, Serenity. Exactly. That's the second one. So we have the Sea of Tranquility and the Sea of Serenity. And that is the two right at the top. Let's see if we can kind of get this out of the way. There we go. So right above, right about in the center, we have a big dark circle, and then just below that, another big dark circle. That is the Sea of Tranquility and the Sea of Serenity. Maria, yes, Matteo. Yes, people used to think they were oceans. Yeah, so incredible. So when astronomers first started looking at these through a telescope, they mistook these as being bodies of water. And so they called them Lunar Maria for the Latin word mare, meaning sea. And so that's where they get the names from. And so these are two incredible Apollo landing sites. Let's jump into the history of where they landed and what years they were. So, what the first one, let's see, the most famous where the first steps were taken, was that in the Sea of Serenity or the Sea of Tranquility? Can anyone take a guess in the chat here? Sea of Serenity or Sea of Tranquility? Let's see. Starship, Tranquility, Frank Johnson, Tranquility. Yes. What's the closest you can zoom in? So I can zoom in about that much. It does get a little bit pixely, so I'm going to keep it right at about there. Oh, here we go. Sweet. I'm able to drag it now. Yay. Okay, so those are the two that we see right here. So we've got right there, Sea of Tranquility, Sea of Serenity. And the Apollo missions landed in the Sea of Tranquility. And does anyone know the year? What year was this? If you could if you could give me the whole date, extra points, even though we're not doing points here. But if you give me the whole date, I want to see it in the chat. And it was the famous location of the moon, of the moon landing. It was where the Apollo 11 astronauts landed, and it's where humans took their first steps. Neil Armstrong and Buzz Aldrin spent a total of 21 hours and 36 minutes on the surface of the moon. So really incredible. Just above that crater, we see the Sea of Tranquility, Sea of Serenity. So excuse me, we've got Sea of Tranquility, Sea of Serenity. July 20th, 1969. Yes, that was the year of the landing. And that was when, it was a huge moment for humanity. Has anyone in the chat, did you live through that moment? Were you watching it on TV? Were you with your family? Did you hear it on the radio? What was it like? I wish I was a moment. Whenever I get asked a question, when would you want to go back in time and relive a moment? That would be it. I would love to witness what it must have been like when humans took their first steps on the moon. Yeah. No, okay, you didn't get to catch it during then. My 10th birthday party was on that date. Stan, that is so cool. What a great 10th birthday party. Det and Fender, I was in high school, stayed up all night to watch the landing. That is so incredible. Wow. Yes, Frank, you saw it also. Wow, that is so incredible. Gosh, that must have been such a moment. What was your favorite takeaway from just witnessing this moment in history happening? It must have just been so awesome. You were 5 years old and it was on black and white TV. John Nolan, that's so cool. Wow. That's incredible. Wow. Okay, so let's explore a little bit now further south. So we've got, further north. So just above that now, here we have the Sea of Serenity. This was another famous Apollo landing site. This was the landing of Apollo 15, where astronauts David Scott and James Irwin spent about 67 hours on the lunar surface. And with 19 of those hours in their spacesuits outside of the lunar module. And they also deployed the Apollo lunar roving vehicle for the first time. And they drove over 17 miles on the lunar surface to study the moon's geology and collect samples. Can you imagine driving on the moon? Okay, so confession, I'm a new driver, and driving, on pavement is one thing. Driving off road is a totally different experience. I can only imagine what it must have been like driving on the moon. I mean, what a road trip, right? Education. Yeah, so cool. Yeah, must have been such a great experience. So I really feel like, I don't know, just one day I really see people on the moon again. I really see humans being on the moon frequently and maybe driving around the moon, maybe doing like lunar donuts. would be pretty cool. All right, so what should we jump into next? We've got a few more things to share about the moon, and then we're going to jump into our next space object. So let's just zoom out a little bit. One more note I wanted to share was something special about these craters. You see, there are a lot of craters on the moon. You can see a lot of different, it's these round, these little circles that you see, impact craters. These are caused by um, objects that collide with the moon, space objects, space debris, like asteroids and meteors, for instance. But there's a key difference between the different colors that we see here. Like, what are the main differences that you see here? If you had to describe to somebody what the craters on the moon look like, and specifically the key differences, what would you say? So, looking at kind of like the texture down here versus the colors up here versus the lines down here. I mean, there's so many cool different things about the craters on the moon. How would you describe that? I'm really curious to hear what you all have to say about that, because it's quite fascinating, and I've got a few things I want to share about that specifically. So let's see what you guys are saying in the chat. It's obviously made of trees. Well, no, but 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 yeah, that's definitely not how we would describe it. Crust is thicker and white. Okay, that's cool. Contrast of the ejection blanket is so pronounced. Starship. Oh my gosh, I love all the knowledge you guys are sharing in the chat. This is so incredible. The seas are also known as maria, made of solidified lava, while craters are the result of meteor impacts. Yeah, so all the I love the description that you all are giving of the different kinds of just visual differences that we can actually see here. There are so many different things that really stand out, just sort of looking at all these different features. Now, about 15% of the moon's crust um, are actually impact basing created by collisions with the cosmic debris that filled with lava and other lunar materials, somewhere between about, it's estimated right now, between 1 to 4 billion years ago. But the big difference between a crater and a basin, it really has a slight difference between sort of the size and yeah, really the color. So you can see the color is very different, but specifically, a basin, which are these darker regions, are a crater that has a diameter greater than 185 miles. So let's zoom in on that again. So a basin is a crater that has a diameter greater than 185 miles. And so keep that in mind when we're looking at these different craters on the moon. What do you think would cause like a massive, basin, for instance, compared to a crater? What would be like sort of the key reasons that the craters would look so different in size, so different in texture? What would be some of the key differences? And remember, we're talking about sort of the impact. These are impact zones from space debris. So what would you have to say? Volcano, let's see. Seen, okay. Flow of volcano, yeah. All right. Oh, so ready to visit the moon. I bet we'll have an underground base there. Yes, education. Oh, that'd be so incredible. An underground base. Meteor, Yod. Yes. So it really has to do with a few things, specifically the different sizes that are caused, are really caused by the different sizes and velocities of the object that impacted that region. So, zooming in again, can we imagine the size of the object that impacted the moon up in this region compared with, say over here, this crater? Look at the difference in size and even the color, but you're gonna have a difference in velocity. So that is how fast it's gonna be moving, and also how big the object is that actually helps cause the different size of this crater. So pretty cool stuff. Absolutely incredible. Does anyone have any questions about the moon? We still have a few more facts to share here. I'm going to just kind of share them real quick with you all because they're just so cool. I can't leave them out. And then we're going to jump to the next object. For the first thing I wanted to kind of chat with you all about is how do you think the moon formed? Does anyone want to share in the chat how you think the moon formed? What are our ideas right now? What are the current theories? And what do you all think? I want to hear what you all have to say. As there have been a lot of different ideas over the years about how it formed, but there are a few theories that are favored by scientists. One specifically, and it would be about 4.5 billion years ago. So what would, okay, let's see. The remain of Earth became the moon. Collision with Earth. Yes, Kate. Yes, Drac. Yes, Yod. Awesome. Okay, let's see. Oh, amazing. So yeah, so what the current theory is that really is the most supportive and really the favored one by scientists is that the moon formed approximately 4.5 billion years ago from debris resulting from a massive collision between Earth and a Mars-sized body. So some kind of object that was about the size of Mars, and it collided with Earth, creating our beautiful natural satellite, the moon. And this event led to the creation of magma ocean on the moon's surface, which gradually cooled and solidified over millions of years. And recent analyses of lunar samples have provided evidence supporting this theory, revealing that the moon's surface was once molten. So that's pretty incredible to think about how this was probably how the moon formed. I wish I could get a snapshot of what our solar system was like during that time. Oh, it must have looked so incredible. So many moments about just like early moon years, early Earth years that we could have really seen. So let's see. There was one more thing I wanted to share here. Let me check the chat, see what you all are saying. Even iron come from meteors, even water. Yes, part of the inner planets, the asteroid belts. Yes, awesome. Let's see. Then also evident by anomalies, interior of Earth. Oh, love everything that you all are sharing in the chat. Yeah, keep sharing your thoughts and everything too that you've learned, everything that you know, because this is a place for all astronomers to come together, all stargazers to come together and share our knowledge and share what we love so much about our universe and our night sky. I did want to share one more thing, pretty cool, is that if I had asked you guys, true or false, all right, we're going to play true or false, and I want you to type it super fast in the chat, true or false. True or false, the moon is moving away from Earth. True or false? Let's see, what does everybody have to say? The moon is moving away from Earth. True. Okay, but Opal Guy. T, Starship, true. Zach, true. All right, we got so many trues. Anyone with the false? Anyone have to say false? True, true, true. Awesome. Yes, well, you are right. The moon is moving away from us. It's so sad. I don't want to move away from us. How fast or about how far is it moving away from us per year? Does anyone happen to know? Let's see. Does anyone happen to know how far it's moving away from us? At what rate per year? So give me a measurement. So we're going with centimeters here. So centimeters, or do you want to go really big and say it's actually moving away from us at 100 kilometers, per year? 0.1 centimeter, a few millimeter, okay, 2.54 centimeter. Amazing guesses. All right, you guys ready? Drum roll, please. 3.87 centimeters per year. So just under 4 centimeters per year, the moon is moving away. Yeah, so it's moving away from us at just under 4 centimeters per year. Now, why do you think it is? Why do you think that is that the moon is moving away from us? Why would the moon leave us? Well, it's our neighbor. We're existing in space together. Well, there may have been a few overestimates in the chat, but not bad. It looks like everyone guessed right around the value. A lot of people guessed about 2, a lot of guessed about 4. So not bad. Oh, shrinking tidal forces. Yes. So the slow drift is due to tidal interactions between the two bodies. Over billions of years, this movement has led to actually longer days on Earth. Is that cool? And also tidal interactions are due to, well, we talked about it before, the gravitational influence of the two bodies. I've actually got an Earth globe right behind me, and I got to get a moon globe. I have Neptune over there. But imagine those two bodies, they're exerting gravitational influences on one another, and they're constantly tugging on one another, causing changes in their orbits and causing changes in their rotations and even changes in their shape. Yes, I said changes in their shape. It turns out that our massive Earth and our gravitational influence is causing the moon to change in shape. So pretty crazy. Anyone think that the moon or objects generally in space like that can change shape once they've already sort of established a nice orbit in space? What about Earth? Do you think Earth is going to change shape? I mean, no, right? Like, probably not because the Earth is, what? It's a lot bigger than the moon. Would the Earth change shape? What do you guys think? Yes or no? This is Power Hour. Yes or no? Will the Earth change shape? We've got yes, yes, yes. Okay, amazing. It's pear-shaped now. Yeah. Didn't put this in my notes if we want to get the fact check real quick, but um, Earth is often referred to as an oblate spheroid. So if we want to double check that, Earth is already kind of has a funny shape to it. But yes, Earth is also slightly egg-shaped due to the tug of war with our natural satellite, the moon. So yes, the Earth has actually changed its shape because of those tidal interactions with the moon. So pretty incredible there. We've explored so much already about the moon. Are you guys ready to head to the next object? Are we ready to say goodbye to the moon and head on over to our next object? And you're going to be watching this live, or I'm going to keep up the live stream of the telescope as it moves over. I don't have to go outside and do anything. Hopefully, knock on wood, it knows where it's at, so I won't need to go out. We're going to watch it live as it finds our next object. But does anyone know which object we're gonna do next? Any stargazers out there who have been going out at night and looking up at the night sky? What objects have been pretty prominent in the northern hemisphere? Because that's where I'm located specifically. So this is where we're going to be looking at this evening. What objects have been very prominent in the sky? Yes, Jupiter, 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 Jupiter. Okay, let's go to Jupiter. Let me take one more photo of that. Wow, we have been looking at the moon for 40 minutes. Okay, we are going to go to Jupiter now. So welcome to my app. This is how we're going to look for some objects. Oh, may have just frozen. So just give it just a moment. But we're going to head over to Jupiter. Does anyone want to share some of their favorite things about Jupiter? Some of your favorite stuff about Jupiter? As I get my catalog pulled up to look at some objects. Let's see. What are some of your favorite things about Jupiter? Largest planet, yeah. What about the way that Jupiter looks? All right, everyone, I might need to, okay, we are in. Ooh. Okay, I'm gonna let this image finish processing. It wants to take a photo and then okay, photo is processed, amazing. Let's go find Jupiter. All righty. Technical difficulties. Titan, yes. Oh, incredible. The hexagon at the poles, gas giant. Oh, you guys are making me so excited to pull up Jupiter. But my app is just a little bit tired right now. Okay. All right, let's see. Okay. So welcome to my app. Let's try this again. So we are going to check out solar system. We've got Jupiter right here. Right up here. Right, here we go. Everything's mirrored for me. So let's go to Jupiter. And we are going to head on over to Jupiter. Now it's going to take a moment to make its way over to Jupiter. But Jupiter's not too far from the moon actually this evening. So if you're in the northern hemisphere, you want to get outside, especially if maybe you're inspired by this stream, maybe afterwards, go outside, look up at the sky. Jupiter is going to be right next to the moon. Beautiful for observing. And this might take a moment. It looks like it's still processing images from the moon. So just give it just a moment. And let's see. We've got so many cool things shared in the chat. This is amazing. Oh man, gravity is strong. It can squeeze you on Jupiter. Slewing. Well, it is heading on over to the moon. Slew. Oh. Wow. Oh man, I need to take a screenshot of that. Oh, I've never gotten that image before. It's gonna focus a little more on Jupiter, but I'm pretty sure that's Jupiter and the moons. Oh, you guys, you guys. Oh, I'm gonna cry right now. I've like never captured this before. Like where I'm pretty sure that's what, and I'm gonna need to adjust this just a little bit. It looks like a telescope is going a little too. Oh, good, it got it. Okay, okay. So there's Jupiter, but oh my gosh, I'm pretty sure those were the Galilean moons that we just saw. Wow. Let's start enhancing this image and zoom in just a little bit so you can see some details. It is going to look a little smaller right now, but um, oh, it's turning out so great this evening. Oh, I'm so happy. You guys have no idea. So, like I've practiced this so many times, and sometimes it's really hard sometimes to lock in on these bodies. They're so far away. So um, I'm just so happy that it's turning out so well. Look at the details. What anyone want to share what they're seeing? What are you catching here? What are like I know we've got a lot of things that were shared in the chat. So start share. I just want to hear you could see the details, you could see the atmosphere. This is so exciting. So I already saw some comments in the chat. Jupiter is the largest planet in the solar system. Yes, you are right. It is also a gas giant planet, meaning it's composed mostly of hydrogen and helium. So it's a pretty crazy to think about. It's very different than Earth. Earth is a terrestrial planet, and so we're looking at Jupiter as it's a gas giant planet. So with no solid surface, this gas giant's atmosphere is active with storms that can last hundreds of years. So I don't think I saw anyone in the chat, but what is the biggest storm on Jupiter that everyone knows about that you might know about? Maybe not everyone, excuse me, but you hear about in the news like all the time. What is the biggest storm on Jupiter? Okay, we've got a ringer spot, the red eye. Okay, what else? We're getting close. We're getting really close. Yes, also, I just saw a really great comment. It was, I see stripes on the moon. Yes. I also see bands. Yes, those are bands that we see on the moon. That is, sorry, Jupiter, not the moon. On Jupiter, those are that's Jupiter's atmosphere. But yes, Matteo, the red spot. The Great Red Spot is a colossal storm larger than Earth that has been on Jupiter, just massive storm that's been going on for at least 150 years and possibly longer than 350 years. And the storm's reddish hue is still a subject of really scientific investigation. So I'm not able to make out the storm in this view. Let's see. It might be here on this bottom right area. It's a little tricky to see, but it may be right about here, but not confirmed. It does look. What do you guys think? Do you think that looks a little bit like that could be the red spot? Possibly, huh? Yeah, giant hurricane. Yeah. So now, while the Great Red Spot is famous, it's also shrinking and fluctuating in size, and it's been doing this over the decades. And it also, by the way, changes. It is changing in shape. But why is that changing in shape? What do you guys think? So it's a huge storm happening in the atmosphere on Jupiter. The atmosphere of Jupiter is really intense. So what do you think would be causing the change in shape and size of this storm? Let's see. The storm is shrinking, isn't it? Yes, Blaze Bunny. Yeah. Storm is slowing down. Yod. Yeah. So it is actually right now. Right now is what it's thought to be the reason for why the storm is shrinking is because of its interactions with the surrounding atmospheric currents. So yes, the atmosphere is affecting the storm. The storm is in the atmosphere, and so it is causing intense interactions, and it is affecting the storm. And so it's showing how even long-lasting storms, they evolve over time. So pretty cool about that. Let's zoom out just a smidge here. And what are some other things that you guys know about Jupiter? What are some of the things? How about the days on Jupiter? Do you think a day on Jupiter is shorter or longer compared to the Earth? Shorter or longer? So Earth's day is just about 24 hours. What about on Jupiter? Let's see. Starship, much longer. Okay. All right. Let's see. Who else in the chat? Anyone want to say 10 hours a day on Jupiter? Only 10 hours? If gas, no eye out in space. And we'll share some more info soon, Carlitos, about specifically that question. Longer, very short. All right. You guys ready? Drum roll. Jupiter actually has the shortest day of all the planets, completing a full rotation on its axis in just about 10 hours. So, everyone who commented 10 hours in the chat, yes, you're right. 10 hours. That is such a short day. And this rapid spin causes the planet to have an oblate shape with noticeable bulge around the equator. So Jupiter orbits the sun so slowly compared to Earth, it takes Jupiter about 11.8 Earth years to complete one orbit around the sun. So although its year is longer, its day is shorter. So pretty cool. And that's actually one reason why we can't, we actually can see it tonight. It takes months to move from one constellation to another. So Jupiter is visible a lot of times for long stretches of time in our night sky. Now, what about, has anyone heard about the Juno mission or any of the missions that really explored Jupiter? Because we are going to get into some cool things about Jupiter's intense magnetic field. It's magnetic. It actually has one of the strongest magnetic fields in the solar system, being about 16 to 54 times as powerful as Earth's. And this actually causes quite the alarm for incoming spacecraft. So this is something that you definitely want to keep a lookout for, but it also creates some beautiful auroras in the solar system as well. Now, I've got a video that I want to play tonight. So it's just going to be the sound. I'm going to play it from my phone, actually. So let me send this link to myself. And has anyone ever heard of the sounds from Jupiter before? I'm curious. As we're looking at Jupiter, we are going to also explore what Jupiter sounds like. Has anyone heard the sounds from Jupiter before? What causes the sounds from Jupiter? So I've got it on my phone. I'm about to pull it up and play it. But first, I just want to share that. Let's see if anyone in the chat knows what causes the sounds on Jupiter. Someone said a train. No, not a train, but all right, let's get this pulled up. So, by the way, this sound is from NASA, JPL, Caltech, as well as the SWRI, University of Iowa, and NASA JPL sounds from the Juno spacecraft. So I mentioned the Juno spacecraft already. It's a pretty cool looking spacecraft, actually. I'm going to go ahead and show you all what that looks like. Let's see. I think we've got a cool image right here of it. So this is the video. I just want to show you. Spacecraft looks like a fidget spinner. Let's see if you guys are able to see this. So it's a little hard to see, actually. We can maybe share this link in the chat. I'm not sure if we're able to go ahead and post it in the chat, but you can definitely listen to it. But I'm going to play the sounds and I want you to think about what may have caused these sounds before. Okay, it's going to start in just a moment. Do you hear it? So Jupiter's magnetosphere emits radio waves that sound like these eerie whistling sounds that you hear. There's screeching noises when converted into audio, and they're caused by charged particles interacting with its magnetic field. Now, there's going to be a few other sounds I want to play here for you. The video itself does share some information and notes about what each sound is. This one says the bow shock is where the supersonic solar wind is heated and slowed by Jupiter's magnetosphere. And it is also, that might sound similar to a sonic boom on Earth. So this is going to be the next sound. Jupiter's crying. No. Okay. And this is all caught by the Juno spacecraft. Let's hear what Jupiter sounds like. All right. Wow. Well, we're going to end that right there. But those are some sounds from Jupiter. Definitely check it out. I think it's so fascinating that we were able to capture this from a spacecraft. And it tells us so much about Jupiter. I mean, the surrounding layers of Jupiter, like the atmosphere, have these intense pressures and temperatures compressing hydrogen gas into hydrogen liquid, creating also the largest known ocean in the solar system. Let me say that again. The largest known ocean in the solar system is on Jupiter. And it is actually made of only hydrogen. It is liquid hydrogen. So rather than H2O or hydrogen, two hydrogen, one oxygen, which is water, it is made of only hydrogen. So that is pretty incredible. Fun fact for today. Fun fact for any parties that you may go to in the future. Be like, did you know that Jupiter has the largest ocean in the solar system? Yeah, pretty cool. That's a fun trivia indeed, Lutina B. Now, the next thing I want to kind of explore with you all is going to be the formation of Jupiter. So, how do you all think Jupiter formed? How did Jupiter form? So, we talked about the moon earlier, that the moon likely formed from a collision with Earth and another space rock. But what about Jupiter? How do you think Jupiter formed? And I'll give you a hint. There's actually two sort of leading theories right now for the formation of Jupiter. Let's see. We've got a few questions here. So much hydrogen. Yeah, a hydrogen car. Yeah, I love the way you think. Yes. Angel, Angeleva AV says supernova. Okay, we're going to talk about supernovae a little bit later. We're going to look at some really cool deep sky objects also. So definitely stick around on the stream for that too. So let's see. Okay, our failed second sun. Oh, that's cool. Yeah. So fun fact about Jupiter. We'll get into that in just a second. But why it's actually not a star, and why it is a planet. But for Jupiter's formation, there are two leading ideas for how Jupiter may have formed. And the first one is known as a core accretion model, which says that Jupiter first formed by developing a rocky core several times Earth size, which then attracted the accretion of gas and dust in the outer solar system, resulting in a large planet with a predominantly gaseous composition. So core accretion model, it started with a rocky core several times the size of Earth, and then started to attract in nearby dust and gas in the outer solar system and formed this large gas planet. The problem with this model is that the time that it would have taken Jupiter to form would be between 10 million to about 1 billion years. But recent observations of distant stars show that planets really only have a few million years maximum in order to form before the disk that feeds them disappears. So that means that if Jupiter would need at least 10 million years, then how could it have possibly formed if the disk disappeared after only a few million years or less? It doesn't quite add up, but this could also help explain Jupiter's formation, given its distance from the sun, and therefore the lack of debris present from a core. So that's one idea. And that is that core accretion model, if you want to look more into that. The second idea, does anyone know about the second idea? The second idea of how Jupiter may have formed. And I'm really excited about this one to share because it actually goes into one of my favorite personal astronomical objects. It's actually something I studied in my first years of undergraduate research when I was studying astrophysics in my first years of undergrad. And I studied these really cool objects, and we're going to explore those a little bit. We're also going to look at them later in the stream too, or a similar region to them. So this one is about protoplanetary disks. So proplyds, those are the objects I'm talking about. But the theory is actually called the disk instability model, which says that Jupiter formed in a disk of gas and dust orbiting our young baby sun at the time. Because the sun is a star, and when it was young and it was a baby star, it was within this disk, which is the protoplanetary disk. This disk was filled with dust and gas. And within the disk, clumps of matter can begin to form. Think about dust bunnies in your house. I always love to compare it to dust bunnies because dust bunnies, you have all of this literally dust, and sometimes it clumps together and you end up with a bigger piece of dust. Similarly, this is what would happen here. So clumps of matter can begin to form, increasing in density, and ultimately can form planets. So to reiterate, a protoplanetary disk is a disk of rotating gas and dust around a newborn star, which may eventually form planets, moons, and even asteroids. And so within that disk is where some astronomers think Jupiter may have started to form within a few hundred to a few thousand years. So pretty incredible. I love talking about protoplanetary disks. I think they're so fascinating. It gives us a glimpse into sort of the early stages of solar system formations. But also note that this model actually seems to be the less accepted model for how Jupiter formed. And also a key distinction really between these two models is the presence of a rocky core or not. Core accretion model, rocky core. The disk instability model, no rocky core. So that's really kind of the key distinction between these two models. So this is important because if it's confirmed that Jupiter has a rocky core, then it likely formed through the accretion of matter like the terrestrial planets, Earth, Venus, Mercury, and Mars. If no solid core is found, then it likely formed through the disk instability model by pulling gas and dust together under the influence of gravity. So pretty incredible. Those theories are like really, really intense, but also like really fascinating in my opinion. I don't know. I love this stuff. So I find them to be pretty cool. So we're going to dive in before going into our next object. So we've been on this one for just about 16 minutes. We've got a few more facts I'll share, and then we're going to jump into the next one. But I really wanted to share with you all a cool thing. So we were doing a speed round earlier. Yes or no, true or false. Jupiter has rings. True or false? True or false? Type it in the chat. True or false? Jupiter has rings. True or false? I am curious to hear what you all have to say. True or false? True, true, true. Yes, awesome. Yes, yeah. Jupiter has rings. Yeah, it has a super thin ring system. So while it's not as prominent as Saturn, which by the way, I really wish we could have looked at Saturn tonight, Jupiter has a faint ring system composed mainly of dust particles that were really kind of ejected from some of its smaller moons during impacts from comets and asteroids. So it does have a ring system. And we were talking earlier about the atmosphere. There's also lightning strikes that can be like 1,000 times more powerful than the lightning strikes on Earth. So pretty intense. If you ever think about maybe like doing a mission to Jupiter one day, if that's ever in your realm of thought, keep that in mind. Lightning storms are pretty intense. Before we get to our next object, I'm just going to do two more things I want to share with you all. Does anyone know about the most volcanic moon around Jupiter? Can anyone name it in the chat? The most volcanic moon around Jupiter. The most volcanic moon. What is the name? I would love to fly to Jupiter. Frank Johnson. Wow. Yes. Mateo. Yes. Frank Johnson. Yes. Yeah. Yes. Science mom. Io. And for some reason, I like naturally always pronounce it Io. I don't know why, but Io. So Io, Jupiter's most volcanic moon, experiences tidal heating due to gravitational pulls. It gets heated by the gravitational pulls from Jupiter and other moons, and it also causes these volcanic activities. So passage through Jupiter's shadow causes rapid temperatures changes that affects its volcanic activity. So sometimes it's in the shadow of Jupiter, and sometimes it's not. It gets a lot more sunlight. And so this causes massive fluctuations in temperature, and this affects its volcanic activity. One more final thing before we head to our next object. Someone in the chat shared something really cool. They called Jupiter a failed star. A failed star. Has anyone heard about Jupiter being considered a failed star before? I'm going to take a picture one more time of this Jupiter before we head over to our next object. Yeah, so if Jupiter had been about 80 times more massive, it could have become a star. Instead, it remains a gas giant shining faintly in the infrared spectrum. But isn't that crazy? Like, it could have become a star if it was about 80 times more massive. Yeah, really, really crazy. We're heading to our next object now. That's about all I wanted to share about Jupiter. What do you think our next object is going to be? I'll give you guys a hint. It is not a planet. It is not the moon. We've already gone to the moon. What do you guys think it is? Let's see what anyone has to say. Ooh, M31. The Pleiades. How did you know? We are going to the Pleiades. All right, let's head on over to the Pleiades. So you can see here, I am selecting cluster. And I'm actually going to go ahead and type in the Pleiades, which I'm pretty sure is also known as M45. I have like a whole list, by the way, of some vocabulary I want to share with you all. We're going to be using a lot throughout the stream. And one of the things I wanted to share was actually the catalog names. So let's see, we're also going to be going to the Owl cluster. But first, I want us to go to the Pleiades. So let's head on over to the Pleiades. Seven Sisters, yes. What else? What else do you all know about the Pleiades? So cool. M42 is my favorite nebula. Yes, me too. If we are up late enough, we will be able to catch M42. It is still below the horizon for me, or too low on the horizon, and we're not able to see it. So, alrighty. So give my app one more moment here, and then we're going to head over to the Pleiades. But yeah, so many cool things to share about the Pleiades. So now we're going to be going from looking at planets to now looking at a star cluster. But I need to get, I think, because we've been looking at these objects for quite a long time, so the telescope just needs a moment. But what do you all know about the Pleiades? What do you want to share? Has anyone seen the Pleiades before? Have you seen it through a telescope? Have you seen it just with some binoculars? Have you seen it just by looking up with your own eyes at the sky? Has anyone seen the Pleiades? Now, I love camping. I actually did catch the Pleiades before, looking up at the sky, and I was able to see the Pleiades. I was in a dark sky location. So a dark sky location, you can go to a state park, and you can go to an area that will say, hey, we are a certified dark sky location, and you will be able to see, we got it working, yay, 45. Pleiades. Go, 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 go to the Pleiades. Guys, I cannot believe we got that image of the Galilean moons around Jupiter. That was so incredible to see. That was such a treat. I did not expect that. Oh my gosh, so wonderful to see. Okay, let's see what everyone's saying here. All right, Seven Sisters is so misleading. Oh, I love how much knowledge you all have, how much information you all have. Yes, so much to share about the Pleiades. So often called the Seven Sisters, except that it really has actually about 1,000 total stars in the cluster. I mean, we're already starting to see some close-ups right now of these stars in the cluster. But the 7 brightest stars are why it's called the Seven Sisters. And it also is the name of a famous automobile company. Does anyone know the famous automobile company that is named their brand after the Pleiades? Does anyone know? You may have heard about it before. You might even be driving this vehicle today. What would be the company? Subaru, the Opel guy, yes. And Science Mom, yes. Also, it looks like we just got here. So let's go ahead and start enhancing that image. I may also move the telescope around. I can manually adjust it, which I might want to bring one of those other stars more towards the center. Let's see. If you guys want me to zoom in on one or star or another, let me know, and I can also move the telescope around just a little bit. But yes, Subaru is the Japanese name for the Pleiades star cluster. And the Japanese word Subaru directly refers to the star cluster in their language, essentially meaning united due to the close grouping of stars. I love that. Subaru, Pleiades, united. I love that. I just think it's so cool. Now, Galileo was actually the first to observe the Pleiades through a telescope, even though this cluster has been long observed way before Galileo's time with the naked eye. So there is no known discoverer really of the Pleiades star cluster. But this is, this is just so pretty. I love it. It is so nice. I'm going to zoom in a little bit on one of these once I take a photo. Does anyone know which constellation the Pleiades star cluster is part of? Which constellation is the Pleiades star cluster part of? Can anyone name the constellation? And the best time to actually see the Pleiades star cluster is right now. It is in December. And this star cluster is just about 445 light years away. 445 light years away. And personally, it's one of my favorite star clusters to look at. It is quite possibly the most spectacular one to see because theoretically you could see it from Earth with the unaided eye. This means no need for a telescope, but you would probably need to be in a dark sky area with minimal light pollution to see it. And I've definitely caught it before. I even caught it on my phone's camera before. It's pretty nice. Yes, Taurus. Yes. Okay. So not Orion, Carol, but to the SJR boy. Yes, Taurus. And also that Opal guy. It is found in the Taurus constellation. And it does anybody. So if anyone's looking for it tonight, you can catch it. It's not too far from Jupiter or the moon. So where we've been looking this evening in the visible sky area, it's all within really close proximity within the same sort of region. So you're going to want to look over that same area to try and catch it. And we are going to actually look at, so let's see, out of all these stars here, which one would you say is the brightest that we can see? I would say this star right here is probably the brightest. Here, let me move it up a little bit. And we're going to talk about this star a little bit. Do you know the name of this star? Can anyone name this bright, bright star here? Gosh, it's amazing how much you can zoom in. This is so incredible. Education, Polaris. No, but we will be getting to Polaris this evening. I promise. It is not the North Star. It is not Polaris. But you all are getting close. Does anyone in the audience speak Arabic? If you speak Arabic, what is the word for follower? So follower is what the name is of this star. Does anyone know the name follower? Oh, we've got Betelgeuse in the chat. Yes, Betelgeuse is red. Betelgeuse is in the Orion constellation. Orion is still a little too low for me to see right now, but honestly, at the rate that this stream is going, we're probably going to be up late enough where we'll be able to actually catch the Orion constellation rise high in the sky and maybe even look at the nebula. Stuart Damon, Aldebaran. Yes, this is Aldebaran, or the Eye of the Bull in the Taurus constellation. And it means follower in Arabic. Should we start asking people how many Aldebarans do you have on Instagram? I feel like that's just so cool. It's like another great way to just like be bilingual and like learn different languages. Aldebaran means follower in Arabic. It's just so incredible. And the brightest stars that we all actually see here. So that's Aldebaran. We've got a few other bright stars, but the ones that we see here are thought to have all formed within the last 100 million years. So they all are thought to have formed really around the same time as each other, and only about 100 million years ago. And so this means that they are young. What's the color? What's the color of these stars? Rather than me just telling you guys, what color do you see here? Let's see. What color do you all see here? I mean, these are, yeah, so we've got white that was mentioned, blue light, blue giant star. Yeah, so these are hot young stars. These are blue stars. Blue stars will burn out quickly in roughly a few 100 million years. And that's actually pretty fast because how old is the sun? Sun, what's about the age of the sun? Does anyone want to guess in the chat? Maybe you know it, but compared to the sun, that's actually, oh, it looks like that might be an airplane that crossed the telescope's image to the bottom right. So we're going to zoom in a little bit to kind of avoid that area, but it does look like there may have been an airplane that passed through. Yeah, so the sun is yeah, roughly, we can get a fact checker maybe in the chat to confirm this, but roughly about 4.6 billion years old, and the sun will live for billions of years. And so for one of these stars over here that are young, hot blue stars, they're only going to live for a few hundred million with an M versus billion. And so big difference here between those stars. And something so cool about the Pleiades, it really is quite historical. So the Pleiades has been used as a calendar in various cultures. So in ancient Greece and the Mediterranean, when they first noticed the cluster appear before sunrise, it actually marked the start of navigation season, indicating safe sailing. So that's pretty cool. This was like a notice of safety to go out, to go sailing. It was the start of navigation season. So it was used in many ways as a calendar. And a lesser known fact about the Pleiades, if you had to guess which holiday may have descended from the Pleiades, what would be your guess? What holiday may have descended from the Pleiades? PBS Nova, yes, the sun is roughly 4.5 billion years old. Yes, awesome. So what would you say? What holiday? So anyone have a favorite holiday out there? What holiday may have descended from the Pleiades? It's a pretty cool fun fact. Not a lot of people know about this one. It's not confirmed, but it's an idea. It's a possibility out there. Christmas. Okay, we've got Christmas. We've got Halloween. Anyone else? Anyone want to guess anything else? Bear hunting season. Anything else? Any other guesses you want to put in the chat? And let's see. And then, okay, we got St. Patty's Day. Let's see. Anyone else? Easter. All right, you all ready? It is Halloween. But how? That's so crazy. Halloween. Although it's not certain that the Pleiades inspired Halloween, there are some reasons that one could think that it did. For instance, the ancient Celts and the Druids of the British Isles celebrated the pagan festival of Samhain, which ended up really being around the same time. It coincided with the midnight accumulation of the Pleiades constellation. Culmination, excuse me. So the same time as the Pleiades constellation. And so when it reached its highest point in the sky at midnight, the festival was observed around the same time that modern Halloween Day is. And so it's believed to have been what really sort of marked the period of when, the boundary between the living and the dead was at its thinnest. So around the same time that festival was celebrated, was around the same time that modern day Halloween was celebrated, which was around the same time that the Pleiades star cluster reached its highest point in the sky at midnight. So pretty incredible. This is the Pleiades open star cluster. We are going to look at another one, and this one is going to be really, really incredible. It's going to look a little different. So we've taken photos. We're going to actually check out the gallery in just a little bit to do some comparison between these two clusters. But overall, there's estimated to be more than about 1,000 open clusters within our galaxy. And most of them are actually located in the spiral arms of our galaxy. So the Milky Way galaxy, spiral galaxy, out in the arms is right around where a lot of these open clusters are found. So let's head to the next cluster. And we're heading to this one right here in the bottom right, the Owl cluster. So the Owl cluster, also known as NGC 457. So I wanted to ask you all, where do you think these names come from? So you've got NGC, so it's called the Owl cluster, but you also have NGC, this one is 457. Earlier we had the Pleiades, also known as M45. Does anyone know the names, the derivatives of these names that are made of a combination of letters and numbers? Education, messier object. Yeah, Yes. What about NGC? If anyone wants to guess NGC, I'm going to go a little bit into the messier objects. And this is like so cool. I love this history. That's just the history of astronomy, the history of humans discovering our cosmos for the first time. M, so M45, which was the Pleiades star cluster, comes from the Messier catalog. And this was created, this catalog, by the French comet hunter known as Charles Messier. Anyone French out there? I know pronounce the R a little bit differently, but Charles Messier. And he actually coined the name of this catalog, Objects to Avoid. Objects to Avoid. So he was a comet hunter. He was looking for comets. And instead, he was finding galaxies and nebulae and star clusters and was saying that these are objects to avoid. It wasn't until much later that a lot of these objects start to get studied and analyzed. And yeah, and then they got these really cool names. But then you also have NGC, and this is New General Catalog. And so this is an astronomical catalog that lists deep sky objects like galaxies, star clusters, and nebulae. And this is really helpful for astronomers when they are looking for objects, especially if they are doing research. So that's a little bit, but it looks like a little bit on star clusters. But we just arrived now to the Owl cluster. So welcome to the Owl Open Star Cluster. And so it is an open star cluster. I mean, you might have heard me say it before, but we haven't really gone into the details of what that means to be an open star cluster. So similar to the Pleiades, it is an open star cluster, but it's a little bit different because it contains a wide variety of star colors. So as this image processes, I want you to point out to me if you start to notice different colors within the stars than what we saw in the Pleiades. So we're going to probably keep this processing for just a little bit. It's just at about 36 seconds right now, but you might notice already some different color happening right here with this star. What are we starting to see? We've also got this one right up here. So we have a little bit difference, a little bit of a difference here between these between these stars compared to what we saw with the Pleiades. So let me know. Let's see here. What are some differences? So you might be noticing, yes, red. You got red color that's happening here. Someone mentioned pink. Yes. Oh, incredible. Thank you so much, PBS Nova Official. We got in the chats, open star clusters are less dense, relatively young, and can be found in the arms of spiral galaxies. Yeah, so this right here, we can see a few different colors happening. Now, this open star cluster is a little further away than the Pleiades. Does anyone remember how far the Pleiades was or is from Earth? What did I say? What did I mention? How far is the Pleiades star cluster from Earth? Let's see. Because this one is much further away. This one is located between 2,000 to about 10,400 light years away. It's an estimate right now. So anywhere from 2,000 to about 10,400 light years away. And so much further away than the Pleiades. Yes, about 445 light years. So big difference here, Jeff. Big difference here, Denton. Big difference between the distance of these objects from Earth. And this also is a little bit older cluster. So it's thought to have formed about 20 million years ago. About 20 million years ago. It's kind of hard to comprehend sort of the ages like this, 20 million years ago. So I want to ask you all, how do you think astronomers determine the ages of star clusters? How do we think astronomers determine the ages of star clusters? Also going to zoom in over here. We've got some other stars up in this corner. And then we've got some right over here. This looks like a pretty cool bunch over here. It looks like we've got a few different colors happening. The screen may slightly differ from what I'm seeing, but it looks about the same. Let me bring it down just a smidge. Let's see. On star color, yes, amazing. So one of the ways in which astronomers determine the age of star clusters is the types of stars within it. Older, tighter clusters are really the proper breeding ground for more compact objects like white dwarfs, neutron stars, and binaries to form. But they also look at the metallicity of the cluster, which basically just means the types of elements present. So they look at the types of elements that are present within the cluster, and this helps them understand and determine the age of the cluster. Now, I have some pretty fun history to share about this cluster and how it's tied to a very famous alien movie. Can anyone guess what the alien movie might be? Compared to with this cluster, because it does also have another fun name that it's often called, and it has to do with the movie. So, what would be your guess? And if you were trying to figure out, like, oh my gosh, what alien movie? Let me give you a few hints. It's based on, the comparison is based on how the cluster looks. So, it got its name and its comparison to this movie because of a resemblance to the alien in the movie. And I wanna hear if you guys actually feel that way, if you think that there is an actual resemblance to the alien in the movie. But let's see what you're all saying. All right, we've got a lot of ET. We got Arrival, War of the Worlds, Contact. There's so many good alien movies. It's so hard to choose. But yes, ET. ET. This is actually compared to the alien in the ET movie, apparently because of its resemblance to the extraterrestrial in the movie. What do you think? Does it look like ET? It's supposed to look like ET because of the big head of ET and the round googly eyes. So maybe the googly eyes, like, because this bright star right here, um, and kind of like the round head. I'm not quite seeing it, but I mean, hey, why not? I think I think it's cool to sort of think of it in that way. And also, one more thing about this, this is if you're looking for this at night, you're trying to find it, you're checking it out with a telescope or binoculars, look for the Cassiopeia constellation. And this is where William Herschel discovered the cluster. Cassiopeia constellation. The Cassiopeia constellation is one of my favorites because when I was a young 16-year-old student taking my first astronomy class, I remember our teacher pointing out Cassiopeia and teaching us that it looks like the ears on a cat. And so I always sort of pictured it as like, oh, it's like the ears, even though it's really, I think it's supposed to be the crown. If anyone wants to double check that in the chat, the crown of a queen. But I always thought of it as little cat ears. And so now I can't unsee it. So this is found in the Cassiopeia constellation. Let's take one more photo, and then we're going to head to our final cluster for the evening. We're going to have a lot of other objects still we're going to look at, but this one's going to be the final cluster. So let's go ahead and check that. I always see what you all are saying. It looks like Squidward. Squid. I guess I can kind of see Squidward. It just looks like a cluster to me. I don't know. I can't quite make out ET, but okay. Okay, so let's head on over to our next cluster. And this one is going to be a very special cluster. So this one is M15. We're going to search for it in the catalog right here. And it looks like the app gets a little slow when I go to the catalog. It doesn't quite like that. But while we're transitioning here, I'm going to share with you a little bit of a difference between the clusters. So let's check out the chat. We've got Cassiopeia as one of the celestial markers for us when we're navigating the ocean. Oh, that's so cool. Arenadi, are you a sailor? Do you go out in the ocean a lot? That's so incredible. Let's see. Sorry about the slow iPad or the slow app a little bit right now for me. It probably is from just having to connect so frequently to different objects. But thank you for being here and bearing with me. We're going to be looking at a new type of cluster. And this one is not an open cluster. It is a different type of star cluster. Does anyone want to give me another name for a star cluster that you may know about out there? Anyone know of another type of star cluster? Anyone know of it? Yes. Okay. Angel. Yes. Glob. A globular cluster. Oh, incredible. Thank you. Yes. Cassiopeia represents. Oh, it just closed out. Let's open up the app one more time. But yes, it represents a queen wearing a crown is Cassiopeia. But we're gonna head over to M15. Let's try that another time. M15. And this is a globular cluster. Oh, it doesn't want to go. No, not like this. Well, if we don't go to the globular cluster, I may want to try one of our other objects first, and then we can try and check out the globular cluster. But let me see if we can check out another object here. I really do want to try the globular cluster. Let me see. The Great Pegasus Globular Cluster. All right, here we go. By the way, I haven't mentioned it yet, but you may notice that right over here, you have all these details written. So this is going to tell you where it's located. So to the right, it says W, Western Horizon, and then it shows elevation 23 degrees over the horizon. So that's not super high. So I'm hoping it won't be obstructed by a house or anything, because I wasn't able to see this the other night perfectly fine. And so we're going to go, and then it shows you when it will be visible. So up to what time of the evening it will be visible, because these objects don't stay up all night like we do for the stream. But this object specifically should be visible. So I'm really hoping it's going to work. So let's see. So this one, yes, a globular cluster. So does anyone know about globular clusters? Oh my gosh, Denton, I love how much info you all are sharing. This blew my mind. Yes, I was, this is not the globular cluster. Okay, let's see. Just in case, I'm going to enhance the image, but I'm pretty sure this is not at the right location. So I may need to try a different object, because I really did want us to look at a slightly different object. And, while it actually checks that out, I'm going to bring you guys over to my gallery. So these are images that we've taken this evening. We have the owl cluster that we just looked at. We've got the moon, and we got some incredible views of this evening. But I'm going to also check out, just because it might not pull up right now, I'm going to pull up the globular cluster that I was able to catch the other evening. So let's see. Is this? Oh, here it is. This is it. So this is the globular cluster. So we're going to try and still get this. I get a live image of this, but this is what I was able to catch the other evening. And look at its shape. So in the chat, why do you think it's called a globular cluster? Where does the name come from? And it might be quite obvious, but maybe it's not. Maybe you don't actually know. Let's see. So this is the Great Pegasus Globular Cluster. And yes, it is in the Pegasus constellation. This is known as M15 or Messier 15. And it looks a lot different than the other clusters that we were looking at. What are some key differences that we are noticing here? And who remembers what the other cluster was called? What was the other cluster called? So this one, let's see what you all are saying. So we've got stars be part of what categories define stars are part of which clusters? Oh, I mean, that's a great question. So it really comes down to its appearance, but also the age and a few other things that we're going to go into. But yes, Wanagi, open cluster. We just looked at an open cluster. So for comparison, let's actually go ahead and check out the open cluster was this one. This was the Pleiades, very spread out. And then we also had the owl cluster, also spread out. But now we have this one. Oh, excuse me, that's also the owl cluster. We also have the globular cluster right here, the Great Pegasus Globular Cluster. So a key difference really is what you're seeing here. So this one is so much more tight-knit. So the Pleiades and the owl clusters are open star cluster, but this one is a globular cluster, and it gets its name from its shape being like a globe. So think about like the globes I've got back here. So let me actually just grab one. Get Earth. Okay. So just like my Earth right here, this is globe shape. This is spherical. So this cluster, very similarly, is a globe shape, and that's where it gets its name globular from. And it derives from Latin, a Latin word called or for globe, which is globulus, and it means little sphere. Now, globular clusters are actually much older, and they're bigger, and they're much denser than open clusters. This one specifically is located about 330,600 light years away from us. So it's located really far away. And this globular cluster is actually one of the oldest globular clusters known. One of the oldest globular clusters known. This can anyone guess like how old do you think this globular cluster is? As I put Earth back, how old do you think this globular cluster is? If you had to guess. Now, remember the Pleiades open star cluster and the Owl cluster, those were estimated to be roughly 20 million years old. That was the Owl cluster. Pleiades was, let's see, 100 million years old. How old is this? And this is one of the oldest clusters that exists. What would you say? 10 billion years. 10 billion years. Yeah, you're not far off. 12 billion. This is estimated to be about 12 billion years old. And that's crazy considering that the universe's estimated age is like around 13.8 billion years. So that's like really old. That means that this formed like not that long after the universe was born. I mean, that's still like, that's still over a billion years, but still, it's it's still a uh, big, just yeah, shocking difference between an open cluster and a globular cluster. Now, as we mentioned, looking at it, it looks so densely packed, and it is densely packed. It's actually filled with older stars, and it's actually one of the densest clusters that we know of today. So, unlike open star clusters where the stars are loosely gravitationally bound, globular clusters have so many stars that the gravity holding them all together is really, really strong. That these are tightly bound by one another's gravity. And this is what gives the cluster its globe-like shape. That's actually what causes that shape. So these clusters also are, do you think these are older, or these are larger, or are they smaller than open clusters? What do you think? Let's see. Do you think these are older or are larger clusters, or are they a little bit smaller? And also considering how many more stars. Do you think there's a lot more stars, a lot less stars than open clusters? Um, ooh, any planets in there? Oh, really great questions. So many good questions. Okay, so we'll get to that in just a second. So these clusters are actually much larger than open clusters, much, much larger, with tens of thousands to maybe even millions of stars. Whereas open clusters really have only around like 100 to a few thousand stars. So these can have anywhere from, let me say again, tens of thousands to millions of stars compared to, an open cluster like this one that would have anywhere from like a few hundred to a few thousand stars. So a big difference here. Now let's see if I'm able to catch it live. Yeah, no, it definitely is not pointing in the right direction. So I'm going to actually go ahead and slew to our next object. And we're going to look at pictures one more time of next objects. Let's head to, I've got a few more things I want to share first about this cluster real quick. So let's go ahead and open that cluster back up. Here it is. So as we're sort of looking at this right here, what are you able to notice as far as like the colors go? Are you able to notice any differences? And how many of these do you think exist within our galaxy? So we were looking at how many there was a lot of open clusters within our galaxy, but there are also a lot of globular clusters in the Milky Way, and most of them are actually around the bulge or the halo of our galaxy, which is near the galactic center. So um, yeah, so it's pretty incredible. Most of them are located, oh, excuse me, far away from the galactic center. No, the bulge or the halo of the galaxy. You'll be able to see it if you look at an image of another galaxy. The Milky Way, we don't have an actual photo of us. We have a lot of great simulations, but if you look at an image of a galaxy, you'll start to notice a bulge and also the halo. And this is where a lot of globular clusters are found. They're the outskirts of the galaxy, far, far away from the galactic center. But how many? Let's see. So you guys were saying we see a lot of really bright um, colors here. Yeah, and so there's somewhere around 150 globular clusters known to exist within the Milky Way. 150. Now, we are not able to capture too many details here as far as colors go within the image, but we are able to see, say, this right up here. We've got a star right up here that is a little bit different. It's not a blue star. It looks a little bit maybe redder in color. And so the colors are a little bit different in these stars, and that has to do with the age difference. So globular clusters are much older than open star clusters, and they're filled with redder stars. And compared to the open clusters, which have bluer stars, those are much younger, they live fast and die young. Redder stars are older and they live long and, well, they die old. And it turns out globular clusters are filled with beautiful old red glowing stars. So it has a major difference when it comes to those two different kinds of clusters. But something really cool that I was totally blown away by is when this globular cluster was first discovered by a comet hunter, also Italian astronomer Gian Domenico Maraldi in 1746. This was first discovered. It was a globular cluster, super cool, but it wasn't until 180 years later that a planetary nebula, which is a gaseous shell of a dying star, was discovered in the cluster. A nebula, which we're going to look at a planetary nebula tonight. A nebula was discovered in this cluster, a literal nebula. I didn't even know nebulae can form within star clusters. I was totally shocked, but also that makes sense because it's the gaseous shell of a dying star. So a star dies, a nebula is going to form. So a planetary nebula was discovered within this cluster that we're looking at right here. And the nebula's name is Pease 1. It was discovered in 1928 by Francis G. Pease, and it's actually one of 4 known planetary nebula to exist within a globular cluster. So I thought that blew my mind, but there's something even more incredible that someone had mentioned earlier in the chat. Does anyone remember what that was? It has to do with a really crazy space object, a very dark space object, a very powerful space object, a space object in which light cannot even escape. Yes, science mom Amber, a black hole. So one cool thing to note about this cluster is that a black hole was discovered. What type of black hole do you think was discovered? What kinds of black hole exist? Does anyone want to list in the chat what types of black hole you know about? What types of black holes that you know about? There are a few different kinds, but personally, this is my favorite kind of black hole that was discovered here. My favorite kind of black hole, and it's so cool. And it's because it was only theorized until the first one was discovered in 2019. And so let's see what everyone is saying. Okay, stellar mass, super big, rotating black hole. All right, let's see. Has anyone guessed the correct one? I don't think anyone has guessed the correct one. Supermassive, supermassive. No. Mateo Fernandez, intermediate black hole. Yes, an intermediate black hole was discovered. Intermediate black holes are sort of these medium-sized black holes. And the reason that they're my favorite is because they are thought to have formed from the collision of stellar mass black holes. And so an intermediate black hole was discovered here in this nebula. And it is so, so incredible. I couldn't believe it. By the way, it feels like 2019, a lot of things were discovered that year. A lot of things that we're going to also be looking at this evening. But really, like my favorite thing about intermediate black holes is because they are thought to have formed from the collision of 2 smaller black holes. A lot of people in the chat said stellar mass. Stellar mass black holes are smaller, and they are called stellar mass because they form from a star that died and are roughly the mass of a very massive star, like 10 solar masses. In our dictionary, by the way, let's talk about solar masses real quick. Let me pull up my dictionary. Solar masses are what astronomers use to as a basically a unit of measurement to better comprehend the mass of various celestial objects. So it's compared to the mass of the sun, solar mass, sun. And that's roughly about 333,000 Earths. So that is about the mass, which is about 2 times 10 to the 30 kilograms, for anyone who really wants to know, or 4.4 times 10 to the 30 pounds. Or as I like to say, 2 billion sextillions, or better yet, 333,000 Earths. So it's very massive. And to think that it's not the most massive star that exists. And so this black hole would be roughly about 10 solar masses, the stellar mass ones. Those collide, and those can create an intermediate mass black hole. And this is very different than the polar opposite, supermassive black hole. A lot of people in the chat said supermassive black hole. Where is a famous supermassive black hole that we might all know about? Where is this famous supermassive black hole that we may all know about? Does anyone want to put it in the chat? Our galaxy, yes. What's the name of it? Anyone know? And actually, while we talk about that, I'm going to go ahead real quick and I'm going to send our telescope to the next object as we wrap up talking about our globular cluster. So let's head to, oh, it's not popping up here. So let's see what you guys are all saying. Yes, Sagittarius A, asterisk. Yes, Sagittarius A star is at the center of our galaxy, holding a massive 4 million solar masses. So it is a 4 million solar mass black hole. And an even bigger black hole than that, does anyone know? So 4 million solar masses, so 4 million suns squished together, 4 million suns condensed into this black hole. And yes, if anyone just looked at that, yes, we are heading to a galaxy. I'm so excited about this one. But what's an even bigger black hole? Does anyone know the name? Anyone know of the name of the even bigger black hole than, yes, Frank Johnson, Ton 618. How many solar masses is this black hole? This is the biggest black hole that we know about. How many solar masses? Does anyone know? It's crazy. It's a really crazy number. And then we'll kind of wrap up about the black hole that's in the actually while this goes here, I'm going to have us go back to our gallery and look at our cluster. Oh yeah, those are some sun images. This was from the eclipse. But I'm trying to get back to today. Hold on. Here we go. Okay. How many solar masses do you think Ton 618 is? And we're going to go back to our Great Pegasus globular cluster. Okay, someone who was closest here is Science Mom Amber says 60 billion something, I think. Close, 40 billion solar masses, 40 billion suns, 40 billion suns squished together into a black hole. That is Ton 618. It is so insane to think about. Massive black holes. But the one that is located in this cluster, this globular cluster here, is actually an intermediate black hole. And it is estimated to be about 4,000 solar masses. So it's somewhat medium sized, right in the middle of the other types of black holes. And they range in size, really. The one that was discovered in 2019 is around 142 solar masses. And actually, does anyone know about the one discovered in 2019? Astronomers discovered it from gravitational waves that were produced from the likely collision of 2 smaller black holes. And so 2 smaller black holes collided, formed the medium-sized one. So pretty incredible. We're going to now head over to a galaxy, and there it is. We have the Andromeda Galaxy. I'm going to do a quick movement here. Let's put on slow mode. So for anyone asking, there was a few questions in the chat. We are using a unistellar telescope. This is a digital reflector telescope, and I am controlling the telescope right now through an app. That right there is the Andromeda Galaxy. I'm just going to get a little bit more over on it, kind of center it up in the screen for you all, and put it a little bit higher. How's that looking on this TV, on the computer? Oh, whoopsie daisy. There we go. Okay. That looks good. All right, let's start to process this image now, and we can start to see the details of this. Okay, so this is the Andromeda Galaxy, also known as Messier 31. It also has the catalog name NGC 224. So it has a couple different catalogs in which it hangs out in. And what do you guys know about the Andromeda Galaxy? As I have some water. Oh, awesome. Yes. Okay. So it is bigger. Yes, it is bigger than the Milky Way. It is bigger than the Milky Way. Oh, but look at that image. Look at how detailed it looks. That looks so good. Wow. Okay. I want to take a picture of that real quick. So the Andromeda Galaxy is actually our nearest major galaxy. So it is the nearest major galaxy to the Milky Way. There are closer galaxies to the Milky Way than the Andromeda, but oh, enhanced vision disrupted, it looks like. Okay. It looks like it's good though. Sometimes that can happen if like clouds pass by or an object obstructs the view, sometimes an airplane, but it looks good. It looks like it's doing fine. And so the Andromeda Galaxy is located about 2.5 million light years away from Earth. So 2.5 million light years away. But the closest galaxy is actually a small galaxy. It's a dwarf galaxy. It's in Canis Major. It's a Canis Major dwarf galaxy at only 25,000 light years away. So let's actually turn off the enhanced vision for just a moment, and we'll try and get it back on. What else do you all know about the Andromeda Galaxy? What about its shape? So in what we're seeing here, it does look like it has a different shape than what it actually is. It does look a little bit more like round. It looks like it doesn't have much definition to it, but let's try and get some details here. Let's enhance our view so maybe we can see a little bit more details in the shape. But the Andromeda is actually a large barred spiral galaxy, and it's about 200,000 light years in diameter. So it is bigger than the Milky Way galaxy. And so much larger near us. Oh, that looks so cool. And it actually is one of the few galaxies, because of how bright it is, how big it is, that can potentially be seen with the naked eye. So without using a telescope, you may be able to catch this in your sky. And it'll look kind of like a milky blur in the sky. It'll look a little bit fuzzy. But you should be able to see it and check it out. Look for it through binoculars, look through a telescope. Let me know how it looks to you. And the Andromeda Galaxy is actually named after the constellation Andromeda, which is named after the Greek mythological princess who was married to Perseus. So it's also a part of the largest of the local group of galaxies in which we reside in. And a few cool things about it. Anyone know the fate in which this galaxy and the Milky Way have? What does our future look like? Clash of the Titans. Yes, there is going to be a collision. We are on a collision course with the Andromeda Galaxy. They are expected to collide within a few billion years, forming a new galaxy that, if humans are around, they may call it the Milkomeda Galaxy if they want to. But it's really funny. Found that in the research. Hadn't really heard that before, but I think it's pretty funny. Milkomeda. I like Andromeda and Milky Way. I would probably call it the Andromeda Way, but that's just me. But yeah, so they are on a collision course, and because Andromeda is much larger than the Milky Way, it will actually be engulfing the Milky Way, and so it is going to have a really great collision, and they're going to form one galaxy after they collide. So it's going to be a pretty cool thing. I wish we could, yep, capture it somehow, but there are lots of other galaxies that have collided. One of my favorite galaxies is known as the Whirlpool Galaxy. Unfortunately, we can't see it this evening. I really wanted to try and show you all, but I really wanted to try and capture it because it is an active collision between two galaxies. If we want to get the fact checking in on the Whirlpool Galaxy, there is a dwarf galaxy colliding with a massive spiral, and it looks so beautiful. Let's take one more picture of this. I've actually got an image of the Whirlpool Galaxy. I might be able to pull it up here. I don't know if I have it in this gallery. Yeah, no, I don't see it in this one. But maybe we can catch it if we have a galaxy party in the future, and closer to the summertime. But when do you think, when do you think that this collision is going to happen? By the way, does anyone know when is the collision going to happen between the Milky Way and the Andromeda? What do you think? Can't wait for the day when our galaxies will collide. Yes, Roland. When do you think that's going to happen? 70 million years, says Richard. Billions of years from now, says Education. 400 million years, says Roland Clark. All right, drum roll. Are we ready? Current estimates by astronomers using data from the Hubble Space Telescope estimate that in 4 billion years, they will crash into each other. So about 4 billion years. So we have a lot of time ahead of us. But yeah, about 4 billion years, the two galaxies will collide and become one. But what's going to happen? What exactly will happen? Is it going to be like a lot of intensity and like things flying around? And what do you think is actually going to happen when the collision occurs between the two galaxies? What will be left over? What is it going to look like? Well, I'm curious what you all think. What is it going to look like? Probably nothing. By then, the sun will be destroyed. Yeah, a lot of objects that we know of today will probably be dead. So let's see. Oh, yes. Thank you. PBS Nova. Yes, the Whirlpool Galaxy. Let's open up that link for a moment. Yes, this is the Whirlpool Galaxy. Yeah. Oh, that's such an incredible image. This is from the it says VLA, right? VLA has captured vastness. Oh, that's so incredible. Yeah, so this is indeed it. If you guys wanted to check out that link real quick, this is the Whirlpool Galaxy that I'm thinking about. I wish we could catch that tonight, but it is not visible in the winter skies over in my area. So we'll have to check it out maybe in the summer. But let's see. So very starry nights. Yes. So, okay. So right at about 2 billion years after the crash happens, so about 6 billion years from now, the two are going to merge and become one big, beautiful galaxy. And even cooler, there's another galaxy relatively close by in the sky. Um, but tonight, I really want to try and have us see it tonight. But with the moonlight, we're not going to be checking it out. But it will likely collide with the Milky Way and Andromeda as well. This is the Triangulum Galaxy, and I did actually capture the Triangulum Galaxy recently, so maybe I can pull it up in my gallery. But that is also going to collide with Andromeda and the Milky Way. So they're on this collision course due to the gravity, the gravitational influence of all of these galaxies pulling each other towards one another. And so something else cool is, what do you think it's going to look like when they collide? Is it going to be a spiral galaxy? Is it going to look really defined? Or is it going to be kind of weird shaped? Is it going to be fuzzy and look a little bit odd? Well, you guys write that in the chat. I'm going to check my gallery and see if I have the Triangulum Galaxy, which I may have caught recently. Let's see. No, I don't have that here. Nope. All right. That's okay. We will watch it live. So what's going to happen is an irregular galaxy is going to form. And this is where astronomers think that irregular galaxies even come from. Irregular galaxies likely form from the collisions of galaxies like Andromeda and the Milky Way. They've been all like observed all throughout the universe. There are irregular galaxies already known about, but it is assumed that two galaxies, once they collide, can eventually form into an irregular galaxy. An example would be the two dwarf galaxies near us, the Large Magellanic Cloud and the Small Magellanic Cloud. So that is enough about the Andromeda Galaxy. Let me see what the chat is saying, and then we are going to head to nebulae. All right, we are almost at 2 hours. Woo! How's everyone feeling? Get up and stretch, go outside, see what's in the sky. Bring your computer or phone, wherever you're watching the stream from, and look up at the stars and check out the sky. Um, I would love to hear if some of you get to go outside and actually end up doing some of your own stargazing. That is just personally some of my hope for doing a stream like this, is to inspire someone, if not everyone, to go outside and to observe our beautiful night sky and to look at it yourself and ask questions. So we are going to head now to a nebula. Does anyone know anything about nebulae? Nebulae is the plural form of nebula. You also can say nebulas. I believe both are correct, but I usually say nebulae. But we are going to be going to the Dumbbell Nebula. Oh, yes, that's right. It doesn't have V, it's just Dumbbell Nebula. M27. So it says 4-degree elevation. That is odd. I should be able to see it though, because I was able to see it the other night right at about this time. And if we can't, we can go to another object. But the Dumbbell Nebula, I also captured it the other evening. We have some photos, if anything, that we can check out. It was first discovered by Charles Messier. Remember when we mentioned Charles Messier earlier, comet hunter, in 1764. And it was actually the first planetary nebula ever discovered. Now, a planetary nebula is a type of nebula that I'm curious to hear. It's a type of nebula. Why do you think it's called a planetary nebula? Why do you think it is called a planetary nebula? All right. Yeah, there is a chance that we may actually need to jump to Orion's belt. Antonio Diaz, yes, our stream has now run long enough where we may be able to go see Orion, because Orion is probably risen high enough in the sky. So the Dumbbell Nebula is now, I think, obstructed by houses and trees in the surrounding area, especially because it said it was only 4 degrees elevation. Because this stream has gone a little longer than I estimated, but that's great. I'm glad you all are here. So we actually can't catch it live, but you know what I will do? I have an image from the other night that we're just going to check out momentarily until we head to the next object. And this right here is the Dumbbell Nebula. So this right here is the Dumbbell Nebula, and as we mentioned, it is a planetary nebula. And it looks like a lot of people in the chat are saying it's because it forms planets. Interesting. Okay. Any other questions? Any other answer that anyone wants to share? Why is it called a planetary nebula? Is it because planets form there? Hmm. I don't know. I'm not convinced. If anyone wants to share anything else, it is not actually because planets form there. I am so sorry. Unfortunately, that is not why it's called a planetary nebula. Does anyone give any other guesses as to why it's called a planetary nebula before I share the reason why it's called a planetary nebula? What might actually help is to look at our next object, which I'm going to try and head to. This might be a little more straightforward. Why is it called a planetary nebula? Oh, this is great. Thank you, PBS. So Nova says scientists do not expect. Whoop. Okay. Let's pull up this next object. I'm going to look for. So odd that the catalog section seems to be a little slow. But so it's not because planets form, but because I really want to get this image up. Okay, let's see. Okay, let's see if I can get. Does anyone know of the Ring Nebula? It's a really famous one. Anyone know of the Ring Nebula? We're gonna head to the Ring Nebula. Hope. Oh no, -2 elevation. It has set below the horizon, my friends. I am so sorry. It has set below the horizon. I had estimated these for a little earlier in the evening, but no fret, no worries at all, because I have images of these nebulae. So this one right here is the Ring Nebula. And if this shape does not give it away, then I don't know what will. Why is it? Yes, because it is the shape. Yes, ring. Okay, amazing. Its shape is planetary, is why it's called a planetary nebula. So it's not because planets form, but instead because it looks like a planet when viewed through a small telescope. Now, what's really cool about planetary nebula is because these formed from a star that died. And so when a star dies, it's going to shed its outer layers, but not all stars. There are only certain stars, sun-like stars, stars that are about the size of our sun, about the age of our sun. When our sun dies, it's going to eventually form into something like this. It's going to form into a planetary nebula. Now, I like to usually think about it as like an onion peeling back its layers. So when you peel back the layers of an onion, this is what happens when a star dies. So when the sun is going to die, it's going to expand into a red giant star, and then eventually it's going to shed out its outer layers and form a planetary nebula. And so, because of this, astronomers are able to estimate that when our sun dies, after it expands into that red giant and it sheds out its planetary nebula, there's going to be something left right in the middle. Now, we can't quite tell in this image here. There are images taken by the Hubble Space Telescope where you can see what is right in the center. Does anybody know what would be right in the center of a planetary nebula, specifically the Ring Nebula? What may be right in the center? And I'll give you a hint. It is left over from the star that died. It would be left over from the star that died. Let's see. Neutron star, white dwarf, white dwarf. Yes, a white dwarf star. So right in the center would be the leftover core of the dead star. And white dwarfs are formed when a dying star has already shed out its outer layers. And then you reach its tiny, tiny core. What's about the size of a white dwarf? Does anyone know? About how big is a white dwarf? Is it like super large? Is it like a little bit smaller? Is it like relatively close to the size of the sun? What do you think? We got pulsar, we got chewing gum, brown dwarf, Jupiter size. Jupiter size, interesting. I like it when we compare the size to planets. Let's see, moon size, Mercury, Mars size, Earth size. Yes. White dwarfs are roughly the size of Earth. And some white dwarfs can actually be in a binary system where they can explode and go nova. So that's really cool about white dwarfs. But there's a few more cool things. Now, has anyone heard of a different type of star that is a dwarf? Yeah, white dwarf. But when it cools over time, it's going to be called something else. When it cools over time, since they don't have nuclear fusion in their cores, something happens to them. They cool, they don't have fusion in their cores. And so it's predicted that they would eventually fade into yes, Angel, yes, Antonio, a black dwarf, a black dwarf. And so these are predicted at the moment. The universe right now is actually not old enough yet for any black dwarfs to exist. So none have actually been observed to date, but one day they may form. Isn't that crazy? The universe is not old enough for black dwarfs to exist. That just like really shows you the scale of it all. I mean, it's so incredible. I think one of my favorite things about astronomy is you see the recycling process of birth and life and death over and over again in our universe. I mean, this right here is, the remnant of a star like our sun that died. And then you have the cool, core of the white dwarf that's going to cool even more. And then you have all of that material, all of this leftover material of the star that died. And it's just, I think it's so, so incredible. Something else I want to mention before we move to our next object is that white dwarfs actually are like a cosmological tool. Astronomers use white dwarfs as a tool to measure time and when star formation happens in a certain region, because of their old nature. And so, since stars that form from the core of a star that died, this is what helps astronomers understand, okay, what's roughly the age of this area of the sky that we're looking at? What's roughly the age of this planetary nebula? What's roughly the age of the stars near there? So, I just think the universe's recycling process is so incredible. I think it's so awesome. And one more final thing before we head on to our next object is that these nebulae really are short-lived. They only last for a few thousand years to about tens of thousands of years before fading into the darkness of space. So they don't last long. So let's just take in this image one more time before it eventually fades in a few thousand years to tens of thousands of years. It'll eventually be gone. All right. So while we're here, you know what I'm going to do? I am going to jump ahead to our final object that we had. We can go back to the other ones, but because we're on the topic of nebulae, and because I'm pretty sure Orion has risen in the sky by me, I am going to look for the object that we all have been waiting for. And then we can look at the other stars to sort of conclude then. But I know a lot of you have been asking about the specific nebula, the specific constellation. So we are going to look for this nebula. Let's see. Let's see. We have, I'm going to type it in manually, see if it pops up. Does anyone remember? Yeah. Okay. Awesome. We like already changed. Yeah. So incredible. Okay. We are going to look up. I believe what was. Does anyone remember the catalog name for the Orion Nebula? Anyone remember the name? I'll just type in Orion Nebula. The Great Nebula in Orion. M42. All right, M42. And it is at a 35-degree elevation southeast. So, yes, give us Orion. Give us Orion. Oh, this would be such an incredible nebula to see. It is my favorite. I love it. Yes, Science Mom Amber, literally my favorite. Yes, Marvel 360, the Nursery Nebula. I love the Orion Nebula. It is actually the area of my first research that I did as an undergraduate student at the Hayden Planetarium. If anyone has ever gone out there before, super cool facility. And I studied the Orion Nebula. I studied protoplanetary disks within it. It is a stellar nursery. It is where baby stars are forming, and it's so incredible. As we were talking about the recycling process of space, this is one of the places in space that really truly brings that perspective to me. It makes me realize like how the universe really goes from birth to life to death and over again, death can feed new life, and it does. And so this is one of my favorite regions to look at. I actually saw a comment I want to look at really quick. um yeah, this is so incredible. Yeah, so Marvel 360 said, considering that we are looking at a snapshot of light, chances are the nebula we were looking at has already changed. That light just hasn't reached us yet. That's like such an incredible thing about how light travels through space and how telescopes are able to capture the light. But yes, things are at a far away distance. And so it takes time for the light to get to us. By the time we see it, things may be already different on the other side of the universe. So it looks like this is it starting to get pulled up at the bottom left. We're going to center it off just a little bit more and then dive into this nebula. Now, this nebula is a little different than the planetary nebula. This is not a planetary nebula. Does anyone know what kind of nebula this is? What kind of nebula is this? It is a star-forming region. It is a stellar nursery. Let's actually move this up a little bit. Oops. Oh man, I had it on fast mode. Go a little bit slower. Bring us back to nebula. Okay. There it is. Centering it off here. Okay. Now, I love this nebula because you may be able to see it without a telescope or binoculars. So you'd want to look for Orion, the constellation, and look for Orion's belt. So Orion's belt is going to be those three stars right in the Orion constellation. So you're going to have four stars sort of representing the shoulders of Orion, and then the feet of Orion, and then three stars sort of going up like this. And that is the belt of Orion. And just below that, you may be able to see a slight fuzzy blob. Again, you're going to want to be away from light pollution. And that will be the Great Nebula in Orion. And it is a very colorful nebula. I love it for its colors. I love it for its star forming region. It is actually the nearest star forming region to Earth, located only about 1,500 light years away. And it is about 2 million years old. So it's a pretty incredible nebula. Let's see in the chat what you all were saying. The Sword of Orion is the nebula. Okay, let's see behind the three stars. Yes. Okay, let's see what kind of. So Science Mom Amber said it's a diffuse nebula. Let's see what else has anyone else said. What kind of nebula they think it is? Diffuse emissions. So the Orion Nebula is an emission nebula, which means it emits its own light. Oh, well, I forgot to put on enhanced mode. Trust me, it gets a lot cooler than this when it's on enhanced mode. So it is an emission nebula, so it emits its own light from the bright stars within it that you can see. And oh, yes, here we can see the colors. Oh, this is so incredible. Wow. Oh, and it's only gonna get better too as it enhances. I'm so glad we were able to see the Orion Nebula. Wow, what are some things that you all wanna share about the Orion Nebula? Anything that you know? Has anyone seen the Orion Nebula before? The Orion Nebula is such a cool one. It's definitely a crowd favorite, and, because it is a star-forming region, what do you think exists within the nebula? So, stars, definitely. But what else do you think exists within the Orion Nebula? What else is within the Orion Nebula? So there are stars. We talked about it earlier. We spoke very briefly about these objects that exist within the nebula that are tied to stars. So hydrogen and dust. I'm sorry, gas and dust. Jeff Weiss. Hydrogen education. Yes. What else? What else? They are so it has to do with the gas and the dust, and it has to do with the stars. Yes, baby solar systems. Frank Johnson. Yes. So protoplanetary disks, which would be sort of the not really the baby solar system just yet, but it would be the sort of pre-phase before a baby solar system will form. But yes, exactly. The protoplanetary disks, proplids, exist within the Orion Nebula. And this is such an incredible place to look at these areas for studying these types of disks. And for those who maybe weren't here when we were talking about Jupiter, when we were observing Jupiter, a proplid or a protoplanetary disk is a disk of gas and dust orbiting a young baby star. And so when a baby star forms, it's rapidly rotating, and there's a disk of dust and gas that starts to spin around that star. And within this disk, clumps of matter can begin to form. And this would increase in density, and ultimately planets can start to form. And so this is why we called it earlier. This is why, who was it that said, was it Jeff that said baby solar system? And Frank Johnson, planetary disks. Yes, this is where planets can start to form. And so it's so incredible to think about. So we may be looking at a region in space where new planets can be forming in the solar system. And so a new solar system within the nebula. And so this is why I love this area so much. I love this nebula so much, because this can give us a true snapshot of what it may have been like, years ago, billions of years ago, when the planets first started to form in our solar system. This can kind of give us, like, it won't be exactly like ours because it's not ours, but it can give us like a snapshot of what it may have been like. And this could be a really great region too to potentially look at new planets that are forming. Anyone want to talk about finding life beyond Earth? I mean, I know that would take a long time probably for, the planets to form, but I think this could be such a great start, is observing a nebula like this. Now, the longest that I've processed an image for this nebula has been, oh gosh, maybe 30 minutes, and it really starts to bring out the color. But we're going to snap a few photos so we have those for tonight. But yeah, such an incredible area. Um, Beautiful, beautiful emission nebula emitting its own light from all of the stars within it. Beautiful gas and dust that are formed within this nebula. You can see it with a telescope or binoculars, and you may be able to see it without a telescope or binoculars. Look underneath Orion's belt, and you may catch this 2 million-year-old nebula. So does anyone have any questions about this nebula? Otherwise, we're going to wrap up with two final objects, which are going to be some bright stars in our sky. One of them I know we can see because it is a circumpolar star. The other one, I'm not completely sure whether we will be able to see them or not. They may have set below the horizon. So let's see. By the way, I just want to say thank you all so much again for joining the stream. We're still going to be on for a little bit looking at this image and looking at two other objects. But I just want to say it has been so awesome to be here, to be looking at the night sky with you all. And yeah, it's been so wonderful. So thank you all for being here. I'm going to check out a few other things I wanted to mention. Oh, so before we get into these next two objects, as we process this image a little further, I want to go over a couple of vocabulary terms that are going to be important to note. So we're going to be looking at two stars, and we're going to be mentioning things like apparent magnitude and absolute magnitude. Does anyone want to give like a little quick one sentencer in the chat of what you would say an apparent magnitude is? When we say like that object is an apparent magnitude of 2 point something, what do you think that actually means? What would be your best way of describing an apparent magnitude? And we can also get into absolute magnitude, but we're really going to be talking more about apparent magnitude. But let me see what anyone is saying in the chat. All right, we got without atmosphere, pulsars, brightness. Hank the Tank 7. Yes, it is about brightness. Michael Turner, it is about brightness. But brightness relative to what? Because that's kind of the important thing. You have like absolute brightness and then apparent brightness or apparent magnitude. And so apparent magnitude is really what we're going to be speaking about tonight. And it says, okay, it's closer, apparent. This is Rakshashan. Yes, it's brighter because it is closer, apparent. Yeah, okay. Great. Okay. And then Andy Lim, apparent magnitude is how bright something is based on the distance it's seen from. Awesome. So for us, we're all on Earth. And so at least unless there's any aliens joining this live stream from another planet, hello. But apparent magnitude is how bright an object appears from Earth. And so this is going to be really important because the objects we're going to be looking at, we're going to talk about their apparent magnitudes. And some of them are within the visible eye visibility. And so some of them are actually going to be what you can see possibly without a telescope or binoculars. Again, you're going to want to go to a dark sky location for that. Now, we're also going to say a few words such as zenith. Does anyone know what the zenith is? If you were going outside and you're like, hey, the zenith, it's a direction to give you a heads up. So a zenith is a direction. But which direction is it? If you had to guess. What is the zenith? And then we're just going to talk about one more thing, which is the diagram. Okay, we have Venus to the sun, brightness, stars' intrinsic luminosity, highest point, 90 degrees up. Awesome. Yeah, all of these are great. So the zenith really is, it's the point directly above the observer. So it's the point in the sky, or some will say the celestial sphere, directly above the observer. So when we say, hey, what the Cygnus is in, the zenith, that's going to be directly above the observer. So that's when you go right outside, and that is 90 degrees up. So it's going to be right overhead. And so there will be a few objects that we're going to talk about that are in the zenith over certain regions of the planet. And lastly, just one more final thing as we process this final image and snap a photo. We're going to discuss the HR diagram very briefly. the Hertzsprung-Russell diagram, and this is really kind of a way for astronomers to plot different stars, different kinds of stars, based on their luminosity, which is the total power output of the object, like a star, against their surface temperature or their spectral type. And so we'll just kind of focus on temperature versus luminosity, all the power that they output. We'll speak briefly about the HR diagram because it is useful to understand stars. And again, luminosity, someone mentioned in the chat for absolute brightness, they said intrinsic brightness. That is technically luminosity, is the intrinsic brightness of a celestial object. Basically, a fancy way of saying the amount of energy in the form of light that a star emits from its surface. So just keep those in mind in the back of your head as we explore these next objects. Oh, yes. Oh, be a fine girl, kiss me. Okay, so I remember learning about this in astronomy class. Yeah, it'll help you remember the spectral classifications of stars. Amazing. And yes, oh, okay, 32.6 light years. Oh, I like that you asked this question. It really is helpful to sort of compare. I like to think about it if you have like two friends that are two different heights, and you are putting, like you have one friend who's 6 feet tall, another friend who's 5 feet tall, and you put them right next to each other. You can see the height difference. But if you put the friend who's a little shorter, like 5 foot tall, close to you, and the friend who's 6 feet tall further away, it might line up where they're going to look about the same height. So that's why it's important to put them at a standard measurement. And I don't exactly know why astronomers chose 32.6. If we can put that in the chat, possibly, I'd actually love to know. But it is a standard measurement to just sort of put them at that. It'd be sort of like saying, okay, put everyone at 10 feet. That's what I would have to go with, but I'm sure there's something a little bit more specific about that. And it doesn't look like I have any notes on it. So let's see. That's also 10 parsecs. So it's a standard distance in space to sort of measure, how bright a star appears. But we are going to jump now to an object. Okay, so does anyone know the proper name for the North Star? The alternate name for the North Star? Does anyone know another name for the North Star? Polaris. Yes, Polaris. We are going to go to Polaris. And Polaris is a special one. So, unlike other stars that we may check out tonight, what do you all know about Polaris? This final image is processing, as you can see, like right here. There we go. What do you all know about Polaris? Excuse me. Star. Let's see if it pops up right up on top. Oh no, the app is getting slow. Okay, this may have been the longest I've ever used the telescope in one night. I'm so glad everything is charged. Okay, so let's see. What do you all know about Polaris? We have Polaris, let's see, magnitude, navigation, ship navigation. Yes, it's a great way for navigation. Why is it a good way for navigation? Northern hemisphere, yes. Okay, this is incredible. Yeah, amazing. It's in Ursa Minor. Yes, also correct. We're going to go over that. Incredible. Yes. Okay, so let's find it. Polaris. POL. There we go. Okay. Now, how did I know that I was going to be able to see Polaris this evening? I didn't have to even worry. Has it set below the horizon? Is it still visible? Why is that? Does anyone know of a specific word that would define why it is that I just knew that it would be visible for me? And I am in the Northern Hemisphere. So heads up, that's where we are watching from this evening. What is the reason? It never sets. Yes, it never sets. Amazing, Gary. Yes, Chimp 6. Yes, it never sets. Angel, yeah, exactly. So why does it never set? North celestial pole, amazing. Okay, yeah. So what is the word for a star that never sets? What do you think? So it means that the star is continually visible above the horizon. So it neither rises nor sets. Now, if you travel to Santa's workshop in the North Pole, you would see the star directly overhead in the what? What did we say earlier? What's directly overhead? What's the word for it? It's with a Z. What is directly overhead? Yes, the zenith star, a fixed star. Circumpolar. Yes, events and entertainment. Yes, DJ Uncle Phil. Awesome, Mateo. Yes, Angel, Gary, Zenith. Yep, Science Mom. Amazing. Yes, awesome. Curtis Blake. The other stars appear to go around Polaris. Yes, including the Big Dipper as well as Ursa Minor, or then the Little Dipper. We'll get into those in just a little bit. But yes, Polaris stays nice and stationary. The other stars will spin around it. It is a circumpolar star, which means that it is continually visible over the horizon. And so it neither sets nor rises. So you don't have to worry about missing it at all. And let's see if I put in any other definitions about circumpolar, because there was a few more things I want to share about that. But yeah, so if you do end up going to literally the North Pole, it is going to be so high up, it's going to be in the zenith. It's going to be directly overhead. And what's really cool about this too is if you end up going to the North Pole and you go so far north that all the stars go in a full circle um, around that. But it's also in the southern hemisphere too. So do you have any friends in the southern hemisphere that are watching this? It might be totally different time for you right now. And so if you're at the North Pole, you will see all the stars going in a circle. But if you're in the southern hemisphere, all the stars will also go in a full circle around the south celestial pole too. So you definitely can catch that if you end up going to the South Pole. Okay, awesome. It looks like we've got the star right here. We're going to start to enhance that image. This right here is Polaris. Incredible. So this is the North Star. So let's see what else you all have to say here. Now, although Polaris is not currently the brightest star in the sky, it will indeed stay around the same spot over the northern horizon all year round, which is really helpful for navigation, especially when you're looking for the north direction. So I did see someone in the chat mentioned, what's a beautiful picture. Someone in the chat mentioned it's great for sailing or for navigation. And yes, this is a good star to go to when you are looking for the north direction. Now, what constellation is Polaris part of? We've already mentioned a couple of times, but just seeing if anyone wants to write it in the chat also. What constellation is Polaris part of? Let's see. Oh, and you all also jumping way ahead in all the notes that you all wanted to share too. Yes. Cepheid variable, binary, so many cool things. Actually, if we wanted to do a quick fact checking on the status of Polaris, if it is part of a binary system, if it is a Cepheid variable, if it does change in in brightness as well, that'd be really cool to get in there. But yes, Ursa Minor. So the Ursa Minor constellation. Yes. But what about the Little Dipper? Haven't you also heard about the Little Dipper? So why are we not saying Little Dipper? Why do we say Ursa Minor when I asked about constellation? I'm just so excited. I know that you all know, and you're going to like write the best answers because just based on this chat and what you all are saying, it's going to be so cool. I'm just, let's see. Yes, Science Mom member, because that's an asterism. Yes, exactly. So the Dipper is an asterism. The Little Dipper is an asterism. What is an asterism? Does anyone want to give me the definition of an asterism? What is an asterism? Oh, that's awesome, Denton. As a kid, I remember my dad pointing out the Big Dipper and the Little Dipper. Alan Howell, line of stars. Okay, we're getting close. Not quite a line, but we're getting really close. Okay, let's see. Angel Splash. No, it is not just a term for relay people. It is very different. I guess it's kind of similar, but it is distinctly different than a constellation. Yes, it is a pattern, but it is pattern you will end up seeing within a constellation. So Science Mom Amber got it right. An asterism is a pattern you will see within a constellation. And so the Little Dipper is an asterism in the Ursa Minor constellation, which spins around Polaris as Polaris stays stationary all year round. And so you can see this asterism, you can see the constellation. And so when you're, yeah, next time you're out at night, if you're looking for Polaris, try and look for the Little Dipper. The Polaris star is the top of the handle of the Little Dipper or the tail of the Ursa Minor, which I believe is a dog, not a bear. I think Ursa Major is a bear, Ursa Minor, maybe a dog. But anyone wants to double check that. But yeah, pretty incredible. So that is, if you wanted to look for that, that is the North Star. Oh, I'm going to take one more photo. This looks so great. And then we are going to head to our final object of the evening. Now, I'm not sure if either of these have set below the horizon at this point. So I'm going to go with this one. I know this one should be high enough. It is in the Pegasus constellation. And I believe with the Great Square of Pegasus, because we're looking at the Owl Nebula earlier, it was pretty high up in the sky. So I don't think by now it would have already set. It may have just shifted a bit. So I think there's a good chance that we'll be able to catch this star. So I'm going to look it up. And it is, has anyone heard of this star before? 37-degree elevation. Amazing. Shahit. So Shahit, or is also known as Beta Pegasi. So if it's Beta Pegasi and you're looking at the Pegasus constellation, which star would it be? Just based on its name, which star would it be? Oh, yay. Thank you so much. Orange Kali, Marie, Umaru-chan. Oh, I'm so glad that you joined this stream. It has been so much fun. I really, really am enjoying this. This is awesome. Oh, you guys are all saying no, go stay on. That's incredible. Well, we'll see what other objects we may be able to find. But this is really would be the final one that I actually did prepare for the evening. But let's see what. Yes, the second brightest star. Oh my gosh, amazing. Yes, okay. So if you're looking for a star that has the name Beta in it, just like how Alpha would be the first brightest, Beta is the second brightest star. So this is Shahit, or the Beta Pegasi. And so it is the second brightest star in the Pegasus constellation. And the way you can actually look for it is it's going to be in the upper right corner of the Great Square of Pegasus. Ooh, there it is. Wow. Oh, this is incredible. Okay, I'm going to center this a little bit better, make it a little bit more in the middle. But something to keep in mind. So there's the Pegasus constellation. What is the Great Square of Pegasus? Is that a constellation, or is it what we mentioned before? Oh, I need to put this on slow mode. Otherwise I lose the star. No, come back. Okay, find the star. Oh, I might need to reset it and look for the star. Okay, hold on. So the telescope is, it's a telescope, so it's pretty sensitive. So when you are trying to move it, you're going to want to put it on that slow mode so that you actually can have it move just ever so slightly. Because remember, like, these objects are so far away. So just the tiniest little movement of the telescope can shift you like light years away from the object that you're looking for. So just keep in mind when you're looking for an object. So the Great Square of Pegasus would be an asterism in the Pegasus constellation. Yes, Science Mom Amber, exactly. So the Great Square itself is an asterism in the constellation of Pegasus, and the Beta Pegasi, or Shahit, which is the star, will be in the upper right corner of the Great Square. All right, let's put on slow mode. Let's get this more in the center. Okay, a little bit more. A little more centered. And then we're going to send it a little bit more down. And, oh, I think it just froze. Oh, no. Let's see. Okay, there we go. And we're going to just lock in on it. I think that's good enough. It looks like the telescope doesn't want to move too much. So a few things about this star. Does anyone know about anything about this star? Have you heard about it? Yes, someone says the variability. It is a variable star. It is a variable star. So that means that it changes in brightness. It is an irregular variable star. So slowly changes from a middle second magnitude to about a bright third magnitude. Excuse me. Okay. Woo. All right. So it looks like it's able to get a little bit more a little bit more locked in here. Let's snap a picture really quick. It looks like the telescope is trying to just zoom in a little bit more on it, center it up a little bit better. But yeah, so this is a variable star. And so it is actually surrounded by a gas envelope. So it's surrounded by a thin envelope of gas produced by its strong stellar wind. And as we mentioned, it is part of the Great Square of Pegasus, which is the asteroid within the Pegasus constellation. And despite lacking, despite like the second magnitude, Perseus is actually a well-known um, constellation, but also the star is very well known because of its easily identifiable square shape and also its association with the legendary flying horse. So Pegasus is a flying horse, and you can see the square pretty easily in the sky. So it's pretty well known, very famous, and easily identifiable. And so its fame really spans cultures, appearing in Greek myths as Pegasus and as Ojibwe in traditions as a moose. And so it really has a cool history to it. So this has been part of lots of different history. There's even more Pegasus. The stars have also played an important role in Chinese mythology. So Shahit, which is this star right here, Beta Pegasi, is part of the encampment, which is one of the 28 lunar mansions, while Alpharaz, a star shared with Andromeda, demonstrates the interconnectedness of constellations in ancient stargazing traditions. So it's really tied into mythology, it's tied into early forms of astronomy, like early observations, the first time humans really started to look up at the sky and ask what these objects were. So, what are some noticeable, just yeah, characteristics that you're seeing here? What are some things that you're noticing? So let's see. What is everyone saying here? Amazing. Yay. The Opal guy, I'm so glad you're enjoying the stream. This is so, so exciting. Um, it's 2.1 solar masses. That's kind of cool. Fairly close to our sun. Wow. Yeah. So let's see. Um, and it's also about 340 times more luminous than our sun. So it's actually like a lot brighter than our sun. But it's actually 95 times the radius of our sun. So it's actually a lot larger in size, 95 times the radius of our sun. And it's located about 196 light years from Earth. So not like super far, like the things we were looking at earlier that were, millions of light years away, thousands of light years away also. But this one, 196 light years from Earth. What about its color? What are you all noticing when it comes to its color? Yeah, so let's see. So this is a star. What about its looks lumpy? Okay, you can see the rays of how we draw doodle stars. Yeah, Sarah, totally. It's so cool. Like this is really how we illustrate stars is by seeing um yeah, images of stars just like this. So it's cooler, younger, redder, older. Yes, totally. So cooler, bluer, younger, Alan. Redder, older, um yeah, or hotter. No, when it's hotter, it's younger. Hold on, yeah, I read your comment backwards. So younger stars are usually bluer, usually hotter. Older stars typically tend to be redder. So this right here is it is a red orange giant star. So it is part of the giant category. So it is a giant star, as we mentioned, 95 times the radius of the sun, and it is red orange in color. So let's zoom in just a smidge. Didn't mean to zoom in that much. And this star itself, now it is pretty bright, but relatively speaking, it's actually the 83rd brightest star in the sky. 83rd brightest. Just think about that for a second. So there are like 82 other stars that are brighter than the star in the sky. But this does have a visual magnitude of 2.42. Remember we talked about earlier, we spoke about apparent magnitude. So this has a 2.42 magnitude, which means that you may be able to see it without a telescope or binoculars. And so it right is within that range of seeing objects with the unaided eye, with the naked eye, without using a telescope or binoculars. So this is an object that you may be able to see in the night sky, and I hope you guys get to go out and try and catch this. Um, that's about everything I have for this evening. Let's see if we can just wrap up on one more star. Muroc is a red giant star. I'm going to see if we can catch it at all, zoom in on it. Let's see, and then that will be our final star together this evening. So let's check out. Let's see if I can just find it here. Let's see visible sky area. MIRACH. 62-degree elevation. Okay, so it looks like we should be able to see it. And this way, this will be our last thing that we will wrap up on this evening together. I just want to say again, thank you guys so much for being here. Oh, awesome. Thank you, Jeff. This has been so much fun. I definitely want to do this more often. If you are joining and you missed the intro, hello, my name is Athena Brensberger. I am the new host of the What the Physics show on PBS Nova. So we, are going to be airing some new episodes soon, but wanted to do this astronomy live stream. So I'm so glad that you all are here. I really am. And this has been so much fun. I've really, really enjoyed this. Thank you, Satchel. Thank you for being here. Let's salute to our final star of the evening. And this is a red giant star. And this is actually a very important star for stargazers because it can be used to locate other galaxies, including the Andromeda Galaxy, the Triangulum Galaxy, and NGC 404. So to think that there's a star that is useful to, be able to help navigate to galaxies is pretty incredible. Thinking about just how many objects are used for navigation in the sky, it makes me feel inspired to want to go to more dark sky locations and to be able to navigate just around on the Earth by only using the stars, not a GPS navigation, no map, just using the stars. Could be a fun challenge. All right, so look at that beautiful color. So this is a red giant star, as we mentioned. So it's in its final stages of its evolution, and its outer layers have expanded. So it is getting much larger. It is, again, in its final stages of its evolution. And you want something cool? Do you think our sun will end up like this one day? Or is it going to explode as a supernova? What do we know? What do we think as far as that goes? And this is our final star, and then we will sign off. Oh, this is so awesome. Yes. Okay. So this is what our sun will eventually look like. Our sun is going to end up as a red giant. The sun is going to expand into a red giant star in about 5 billion years, give or take, engulfing the Earth. So hopefully by then, whole humans have evolved into some incredible life form that has achieved interstellar travel by this point. But yeah, we are looking at potentially the future of our sun. And I just think that is so incredible. Again, that perspective of like our universe and seeing things, past, present, future is like so incredible. So this is about 100 times the sun's diameter, 100 times the sun's diameter, and approximately 3 to 4 times the mass of the sun. So 3 to 4 solar masses and about 100 times the sun's diameter. So imagine that. Imagine the largeness, the vastness, the massiveness of the star. So big. Which is why it's so brilliant and so bright. Now, it actually has a relatively cool surface temperature. Because remember, we're talking about a red star, a red giant star. It's near the end of its life. It's getting older. It's cooling down. Its surface temperature is only about 3,800 Kelvin. Compared to our sun, the sun's surface temperature is about 5,800 Kelvin. So that difference, 2000 Kelvin cooler, yeah, but it's crazy to think about how there's this 2000 Kelvin difference of surface temperature, and yet this star is significantly brighter, almost 2,000 times brighter than our sun. The star's almost 2,000 times brighter than our sun. I mean, that's incredible. And yet it's like so much cooler. It's the universe just never ceases to amaze me. So yeah, I think this is pretty awesome that we get to sort of see a star. That is what our sun is eventually going to look like. And to kind of wrap up on this star, we mentioned that that last star, a lot of people said was a variable star. What about this one? Do you think this is also a variable star? And if you don't remember what variability is, it means that it changes in brightness. It goes brighter, dimmer, brighter, dimmer. And that's caused by different kinds of things. It can be caused by so many different types of things in space. And we'll actually use my light right now as an example in just a little bit, but I want to see what the chat has to say. Pulsar, quasar. Oh, I know. It would have been so cool to look at a quasar tonight or a pulsar, but nope. Okay, yes, it is very much a variable star. Yes, it is a semi-regular variable star, meaning its brightness varies slightly from about a 2.01 to a 2.10 magnitude. So 2.01 to 2.10 changes by about zero point 0.9 when it comes to its magnitude. Um, but not all stars are variable. Astronomers have learned that some of them are variable because they may be nearing the end of their lives and maybe ejecting mass into space and could be going supernova when it dies, or that they are part of a binary system and get momentarily brighter or dimmer when orbiting stars pass in front of each other. So I'm going to use my light demo as just a little example. Now imagine that this is the star we're looking at, and my hand is going to be another star. So actually, I'm going to use the lens of the telescope cap. But it's not fully opaque sometimes, so I'm actually going to remove this telescope cap. Has a sort of shield like this that helps me sort of focus the telescope on the object. So I'm going to use this as an example. So say that my light is the star that we're looking at. Another star may be passing in front, momentarily blocking the light, causing it to dip in brightness and then get brighter again. And this happens. This happens quite frequently. We didn't put this in the fact checking, but we might want to double check. But from my understanding, most stars actually form in binary systems or form with other stars versus being alone like our sun. And so for this being a binary star, we see its variability changing, its apparent magnitude changing, getting dimmer, brighter, dimmer, brighter. And so that's because, well, as we mentioned, the star has a companion that is orbiting with it. And so it has at Merak, the star we're looking at, has at least one companion star in a distant orbit. And it also has a deep companion called NGC 404 as well. So some final notes about this one is where it's located. It's located in the constellation Andromeda, about 2,000 light years from our solar system. And I just remembered something I wrote down here about the Andromeda Galaxy that I totally forgot to mention. The Andromeda Galaxy was thought to be a nebula for a very long time, and it wasn't until I believe it was Edwin Hubble had realized and discovered that it actually was an entirely separate galaxy. And for a long time, it was understood that the Milky Way was the whole universe. And so it wasn't until the Andromeda Galaxy was really it's discovered that it actually was a galaxy and not a nebula. And it was so incredible, and this was so groundbreaking, and this led to so many incredible areas of study and research and stuff, especially when it comes to like the expansion of the universe. But we won't get into all that right now. But I mention it because this star right here is located in the Andromeda constellation, about 200 light years from our solar system. So that is about everything that we have this evening. We may still get a few more things popping in the chat for fact checking, because I did just throw out a few extra things out there that I think are pretty cool. But yes, Henrietta Swan Levitt, Alan Howell. Yes, exactly. Oh, I love how much you guys know about space. Yes. Oh, thank you. Amazing. Oh, so on top of it. Thank you so much to our friends who are helping with fact checking. Thank you to all of our friends who joined the stream. Yes, most stars form in multiple or binary systems. This is so incredible. This has been such a fun stream. we're going to take one more photo of this star right here so we can save it. Maybe we can post this later on one of the social media pages. But thank you all so much again. My name is Athena Brensberger. We're going to have some more episodes coming out. I also go by Astro Athens is my name on other platforms, but it kind of is like the same Athena, Athens. And yeah, so I'm just want to say thank you all so much for being here. I take my telescope out so often. So I'm hoping we get to do another stream like this in the future, at least maybe seasonally, because we have so many beautiful constellations that we can see in spring and in summer as well. So maybe we can do something again like this in the future. But I just want to say this was so much fun. Thank you all so much for joining. I'll keep the chat sort of commenting a little bit more for just a moment as we sort of just wrap up and look at this star together. Oh, it was so incredible. I think that's about everything that I've got here. Yeah. All right. Awesome. Well, thank you all so much again. Have a wonderful evening. I hope you took away something inspiring from the stream. If not for just watching it, but for really, I hope that you get to go outside. I hope you get to look up at the night sky, you do your own observations, and you ask your own questions about the universe. So thank you all so much. Have a wonderful evening. And until next time, ad astra, per aspera, to the stars. Thank you all so much. Have a wonderful evening. Bye, everyone. Goodbye.